Okay, right. Okay. All right, let's do it like this. You have your people call my people, and we'll get this thing done, okay? All right, good.
Hey, Jordan?
Uh-huh.
When do you get that phone activated?
Tomorrow.
Okay. All right, well, hi, everybody. We're back. We're going to do test 2 today. And we're starting writing with passage 1, physics. All right, this is mechanics passage, question number 1. In the absence of friction and air resistance, D would be the greatest for which block? All right, so if we take a look here, these blocks are sliding down the ramp. Let me get the... We've got each block sliding down the ramp. Now, if there's no friction, each block is going to increase, it's going to accelerate down the ramp at the same rate. If there's no air resistance, each block will accelerate down the ramp at the same rate. So they'll leave the bottom of the ramp with the same velocity. And if they do, the distance that a projectile moves depends upon the velocity, given no air resistance. So each one would be the same. Answer choice D is correct. Number 2. Which of the following helps to explain why the distance D is greater for the iron block than for the styrofoam block? Okay, so we take a look here at our possible answer choices. The coefficient of friction is greater for the styrofoam block. If that were true, would that help explain why the distance would be greater for the iron block? And that would be true because in the coefficient of friction is greater, it's going to slow this styrofoam block down, and it will not have the same velocity as the iron block when it leaves. So it's not going to have the same distance.
Yeah, it could actually, I mean, if it was styrofoam, you could imagine the block not sliding at all.
Exactly. If you imagine the coefficient to be very great, the block would even stop sliding. That's a good technique in physics to take things to the extreme.
Mm-hmm.
Okay, so 1 is definitely true. Number 2, the styrofoam block experiences greater air resistance.
That one's simply not going to be true because the styrofoam... The question is, why is D greater for the iron block than for the styrofoam block? The styrofoam block is going to be moving slower than the iron block, so there's no way that it could experience greater air resistance, because one of the functions of air resistance is going to be the velocity with which the projectile moves through the air.
Right. That question almost stumped me. That one almost stumped me there. And they both have the same size and shape, so the air resistance is going to be the same. So 2 just simply isn't true. It's a false statement. Number 3, the force of friction is greater for the styrofoam block. And number 3 is also incorrect. It is just false. So the only possible answer choice there is A, 1 only.
Right. For 3, the force of friction could be greater for the styrofoam block, but it's not necessarily greater. Right? We could imagine a circumstance where the force of friction was not as great on the styrofoam block.
Right. What we could do for number Roman numeral 3 is we could actually take a look and see force of friction equals the normal force times mu. So for the styrofoam block versus the iron block, the mu is 3 times greater for the styrofoam block, and the normal force is going to be mg. And for the iron block, you can see, compared to the styrofoam block from table 1, is about 8 times greater. So that for the styrofoam block, it's about 8 times less. So the force of friction is less than for the styrofoam block. So that's why 3 is not correct.
Got it. Okay.
So answer choice A is 1 only. Okay, question 3. Assuming frictional force on each block is constant, how does the velocity vary with time while a block slides down the straight section of ramp? So just a straight section of ramp here, and we're assuming that the frictional force is constant. All right, if we have constant force, that doesn't mean that doesn't mean no force, and this is really the tricky part. If there's constant force, we should get constant acceleration. And from F equals ma, m is constant. If F is constant, a should be constant. And if we they say velocity, how will velocity vary with time? Acceleration is the rate of change in velocity. So if acceleration is constant, the rate of change in velocity would be constant. So it would increase linearly with time. Answer choice B. 3B is correct. Question number 4. If friction were negligible for the ice block, what would be the approximate velocity of the ice block as it slid off the ramp? Well, so we say there's no friction. Now we're just going to have to figure out what the velocity is. And if there's no friction, we can just take the total energy of the block here, and all that energy is potential when it starts, and turn it to total kinetic here. So the total potential energy, and let's call, when we do potential energy, we're looking at mgh. So let's call h. We can really choose whatever we want to be our zero value for h. So let's choose right here to be the zero value for h. This way, this value, when the block is down here, h will be 0. So the total height is not 90 centimeters, then it would be 45 centimeters. Okay? So we have 45 centimeters here, and g is 10. M for the block is...
For the styrofoam is 10 grams.
10 grams, okay, and that's going to be that's my initial potential energy. All of this energy is going to change to kinetic, which is 1/2 mv squared. Now 10 was m. We could just cancel these m's out, right? And we'll bring the 2 over here, and we end up with v squared equals 2 times 10 times 45. I'm about to make a mistake. What mistake? Right, the 45 centimeters. I need to change that to 0.45, right? Because this is in meters. We need to have this in meters. So we end up with the formula v equals the square root of 2gh, which is 2 times 10 times 0.45. And let's round the 0.45 to 0.5, so we get 1 times, we get a half times 2 is 1 times 10, so we get the square root of 10. V is roughly 3. And if we take a look at number 4, answer choice B.
Best answer.
Okay. Notice rounding is always a much better idea. We get here they clearly rounded the answer choice to 3. It's not exactly 3. Okay.
And John, you used the value of 45 centimeters for the height, so to simplify the problem, right? When we
exactly. I could have chosen here 90 centimeters. Then when I get here, this term would have to be mv squared plus mgh, right? And that I'd have to use this extra mgh. Instead, I chose this to be 0. Since this whole thing is 90 and this is 45, this first part is 45 as well.
Because
so
what we're really concerned with is how the potential energy changes from the top to the bottom only of the ramp. So we're changing that potential energy to kinetic energy only on the ramp system. And then
exactly, only while it slides is what we're concerned with.
Got it.
Okay. Question 5. Based on the results of the experiment in Table 1, which block most likely experienced the greatest frictional force along the ramp? Well, if we take a look at that, we're going to go back to the force equation here. So the frictional force equals normal force times mu. And we see that the iron block clearly experienced more than the styrofoam. We already figured that out, right? And I'm going to use proportions here again. Let me write that up here. So frictional force equals the normal force times mu, the normal force being mg. And I'm just going to look and see. The iron block is, let's see, how many times? It's 8 times greater approximately than the ice block in terms of, you know what, let me show you the table here. So if we take a look, if the iron block is 8 times greater than the ice block in mass, and it has a greater coefficient of friction, iron is going to have a greater frictional force. So ice is out. Styrofoam we see that the iron block is
80 times.
80 times. Yeah, I put 8 here, but it's 80 times heavier. And the coefficient of friction for styrofoam is only 3 times greater. So 80 here and 3 here means that the force of friction for styrofoam is going to be weaker. Let's compare the wood. When we compare, the wood has a slightly greater coefficient of friction, but the iron has a many times greater mass, right? More than 10 times greater mass. So this gives the iron block the greatest frictional force. So rather than plug everything in and solve the frictional force for every one of these, I'm looking at proportions, and I'll compare the proportionalities for each one. So we end up with choice 5, the answer is A, the iron block.
And it's really intuitive to do it the way that John just did it, because I think for a lot of students it's going to be sort of intuitive, or they'll have this wrong intuitive concept that the styrofoam block would experience the greatest frictional force, because we've probably all as kids played with styrofoam and maybe let it roll down or slide down a ramp and it's stuck. And so you say, wow, there's a lot of friction there. And of course the difference is, yes, there's a frictional force holding that styrofoam, but the thing that's working here is that the downward force along the ramp on the styrofoam block, because its mass is less, is less. In other words, the force pulling the styrofoam down is less, so you need less frictional force to hold it on, versus the iron block, a lot more massive. Gravity's going to affect it much differently. It's going to slide right down.
Exactly. It's a net force that accelerates it. So just because the iron block has the greatest frictional force upwards doesn't mean it'll move the slowest.
Right.
It's actually going to move faster because it also has the greatest weight and the greatest force down the inclined plane.
And that's just something you have to get your head around on MCAT, because this is the way that they're going to test it. And if you're not thinking about it conceptually, it could screw you up.
Okay, question 6. The specific gravity of the ice block is. So if we take a look here, do they give us any information in the table about ice? They don't really. What you need to know about what happens when water turns to ice.
You form hydrogen bonds and it gets less dense.
Exactly. Ice will expand. When water forms ice, ice expands. So if I have this much water and I turn this water, this is liquid water, I turn that to ice, maybe it gets to be this big. Each one has the same mass. Density is mass over volume. Since mass stayed the same and going from water to ice, the volume went up, that means density is going to go down for ice. And we know that the specific gravity of water is?
Specific gravity of water is 1 or 1,000.
Exactly. So the specific gravity of water is 1. The specific gravity of ice is going to be less than 1. Specific gravity, by the way, is going to equal the density of some substance divided by the density of water. So in this case, if it's water over water, that's why specific gravity of water is 1. If it's ice, we see that ice has a lower lower density than water, so this number is going to be less than 1. Answer choice 6A is correct.
Great. I just want to clarify, John. I said specific gravity of water is 1 or 1,000. It's the density of water is 1 or 1,000. Specific gravity of water would be 1.
Good. Okay, question number 7. The students decided to repeat each trial several times. Why is this advisable? This is just experimental reasoning question. Best answer choice here is B. More trials would allow the students to estimate the precision of their data. So with each trial, if I drop the iron block down here and it strikes the carbon paper, if I do it a second and I measure D, and I do it a second time and I measure D, D may be slightly different. And this would be because I am not, because my estimates are not perfect. Because the way I slid the block might not be exactly correct. So if I do it many times, my data will become more precise. Question 7, then best answer is B.
B.
Okay, we're back with passage 2. In passage 2, let's start writing with question number 8. In equation 1, how might HF most easily be collected? Well, if we take a look in this experiment, what are we going to have? We're going to have two solids, the calcium fluoride and the calcium sulfate. Then we're going to have these in a liquid, hydrogen sulfate liquid, or sulfuric acid liquid, with HF gas. So we're going to want to separate out that HF from the H2SO4. The way to do this is distillation. It's really the only way. And it's because the HF is going to have a much lower boiling point than the H2SO4. Extraction is not going to work. This is based upon polarities. Crystallization, HF is not a solid. It's not going to crystallize before H2SO4. And then filtration is not going to work either because HF is not a solid. So our best answer here is distillation, choice D. Okay, question 9. According to the passage, which of the following is the most likely product of H2SO4 and NABR? So we have NABR plus H2SO4. And your first instinct might be look at equation 1 and see, okay, calcium fluoride, this is similar to calcium fluoride. In fact, let's look at equation 2. It's even closer. Sodium chloride plus H2SO4 goes to HCl plus NaSO4. So we might think we'd get HBr plus sodium sulfate here. We might think that's the case, but it's not going to work. And the reason it's not going to work is because in the passage they tell us, right after equation 2, in analogous reactions with H2SO4, the salts of both hydrogen bromide, right, that's sodium bromide is a salt of hydrogen bromide, and hydrogen iodide do not produce desired hydrogen halides because Br- and I- undergo oxidation. All right, so if Br minus and I minus undergo oxidation, oxidation is what?
Oxidation is loss of electrons.
Exactly. So we would not expect to have Br minus or I minus, and we would expect it to be at its next oxidation state, which would be the oxidation state of Br minus is -1, and we expect it to be, if it loses an electron, what would be the oxidation state?
If it loses an electron, it would be +1.
It would be 0.
Oh, 0.
We go from -1, it'd be 0. And Br, in what form would Br be? If it's 0, it would be Br2, right? This has an oxidation state of 0. So this is what we're looking for. The HBr we do not get because the passage tells us that. So A is out. B is out because H2Br makes no sense, right? It's not going to be Br2 minus. It's going to be Br0. And BrOH would be Br plus. We're looking for Br0. That's answer choice C. Tough question, but question 9, answer choice is C. Question number 10. Which hydrogen halide is expected to have the highest boiling point? Whenever you think about boiling point, on MCAT, the first thing I look at, what's the first thing?
Hydrogen bonding.
Hydrogen bonding. Which one of these species hydrogen bonds?
HF.
HF, there we go. And that's the only species that hydrogen bonds, because hydrogen bonds you need an N, O, or F for hydrogen bonding. So only A hydrogen bonds.
Nice.
Number 11. The hydrolysis of nonmetal chlorides is not an oxidation reaction. That's an important statement in this question. Hydrogen chloride can be produced from the hydrolysis of SiCl4. So SiCl4, we can produce hydrogen halides, right? HCl. Hydrogen chloride can be produced from the hydrolysis of SiCl4. Which of the following is a product of the hydrolysis of SiCl4? All right, if this is an oxidation-reduction reaction, what do we need to do here with Si? Every answer choice has Si in it. This is the key here. Every answer choice has Si. So what is the oxidation state of Si in SiCl4?
Got to be +4.
Right, because each Cl is going to be a Cl minus, so it leaves us with Si in an oxidation state of +4. And this is an oxidation-reduction reaction.
It's not an oxidation-reduction reaction.
Oh, it's not an oxidation. Thank you. It's not an oxidation-reduction reaction. So we look at answer choice A. What's the oxidation state of Si?
That would be 0.
0.
Elemental form.
And answer choice B, each OH is a -1, so that would be a +2 for Si.
That can't
Answer
be right.
choice C, each OH is a -1, so that'd be a +3. Only choice here is D, SiOH4. Answer choice D. So this isn't a matter of like knowing, oh my gosh, what is the hydrolysis of SiCl4? What does that mean? We add water, it's going to break up. How does that work? This is a matter of reading the question, thinking about the basic science, and recognizing oxidation reduction. They really told you right from the front. This is just, do you know what the oxidation state of SiCl4 is?
Right,
So,
and if we're not having an oxidation-reduction reaction, the key is that oxidation state is not going to change. So Si starts at +4. If it's not oxidized or reduced, it's going to end at +4, and that's essentially the science that's going on in that question.
right. These questions look really tough, but if you think basic science, it turns out that the science you have to know is really not so tough.
Pretty simple.
And they're very good at making you think, wow, I really have to know the science here. All right, question 12. Hydrohalic acids other than hydrofluoric acid will not react with SiO2 to etch glass. Which of the following is the best explanation for this? So they're saying only hydrofluoric acid is going to etch the glass. And they told us in the last paragraph, because hydrofluoric acid will react with SiO2 to produce hexafluoric acid and water. Hydrofluoric acid is used to etch or frost glass. So let's take a look now. The best explanation for why other ones won't etch the glass. A, the other hydrohalic acids are not acidic enough to etch glass. How about that answer choice?
No, that's just ridiculous.
We know that's not true, right? The strongest acid for the hydrohalic acids is which one?
Hydroiodic?
Exactly. So if we take a look here, HF, HCl, HBr, and HI, this is the strongest acid here. So it's not a matter of HF being the strongest acid. That's not why it etches glass. Okay. And you need to know that, by the way, that this is the strongest acid. The acid strength goes weak to strongest here. How about B? Fluorine is the only halogen that is more electronegative than oxygen. Is that a true statement?
Well, it sure is.
It is a true statement. Fluorine is the most electronegative element on the periodic table, and it is more electronegative than oxygen. Chlorine is less, bromine is less, iodine is less electronegative. Remember, electronegativity increases this way and up. Okay. Also, you should recognize that from NOF, the reason these hydrogen bond is because they're the most electronegative elements. So only fluorine is more electronegative than oxygen of all the elements.
So that increase. So to answer the question, that increased electronegativity affects the chemistry that's going on here, and that's why.
Apparently, but what we've got so far, at least in my mind, is we've got B as a true statement because it's such a tough question.
Okay.
I know A is a false statement, B is a true statement. Let me look at C and D and hope that they're both false, and then I don't have to think about that more difficult science.
Great. Okay.
So C, fluorine is the only halogen with a positive reduction potential. Does fluorine have a positive reduction potential? So that means that if we start with fluorine, and reduction is we add an electron, right? What we would get F minus. Is this a positive reduction potential?
Probably.
It is, right? Fluorine likes to be F minus. How about chlorine?
Again,
What do you think?
I would say yes.
Yeah, positive reduction potential, okay? I should really write it like this. Okay, so this also would have a positive reduction potential because it would happen spontaneously. And so we know then that C is a false statement.
Okay.
How about D? Fluorine is the only halogen that can achieve a +1 oxidation state.
Well, it can't.
Fluorine can achieve, do we see, I'm sorry, you said?
We can't have a fluorine positive.
We cannot.
Right.
Right, exactly. Fluorine doesn't do this. So fluorine is not the only halogen that can achieve a +1 oxidation state because it doesn't achieve a +1 oxidation state. We know D is false. So we know A, C, and D are false. B is a true statement. It's the only possible answer choice.
Great.
So B is the answer. Okay. Question 13. HF is a weak acid. The relative acidities of HCl, HBr, and HI cannot be distinguished in aqueous solution. So they're saying in aqueous solution, these three have all the same acid strength. And that makes sense because all three of these are strong acids. They totally dissociate. HF is a weak acid. Okay. But still, HI is a stronger acid than HBr, which is stronger than HCl, but not necessarily in an aqueous solution. All right. The relative acidities of HCl, HBr, and HI cannot be distinguished in aqueous solution. Which of the following is the best explanation for why this is true? Another tough question. This passage is a tough passage. A, H2O is a weaker base than Cl minus, Br minus, and I minus. All right. If we take a look, let's take a look what they mean. What does a base do?
Abstracts protons.
Right. A base accepts protons. So here I have a proton, and here I have Cl minus, Br minus, or I minus. And if H2O is a weaker base than this, what does that mean? Where would this OH plus go?
It would go to the stronger base.
It would go here. What do we think is going to happen when I have this mixture here? What do we know happens? When I add HCl to water, what happens? Totally dissociates. And that H plus doesn't float around by itself, does it? It never floats around by itself. It is always here. So in other words, water is a stronger base than Cl minus. Okay?
So A has to be false.
A is a false statement.
Right.
OH minus is a weaker base than Cl minus, Br minus, and I minus. So let's take a look. Let's compare OH minus to Cl minus.
Well, this one kind of looks ridiculous to me because if water is a stronger base than Cl minus, then this is a stronger base than water.
Exactly.
There's no way B can be the right answer.
Right. That's a ridiculous statement, so B is false. C, H2O is a stronger base than, we just said H2O is a stronger base than H+, so it does accept. So C is a true statement, not necessarily the right statement, but true. A and B are false. How about D? OH minus is a stronger base than Cl minus, Br minus. OH minus, this is also true. So we have two true statements here. B, we have C and D's true statements. We have to figure out which one answers the question best. Again, the question asks, the question says, the relative acidities of HCl, Br minus, and HI minus cannot be distinguished in aqueous solution. Which of the following is the best explanation for why this is true? Okay, so the correct answer is C. H2O is a stronger base than Cl minus, Br minus. And what we want to look at here again is when I add HCl to water, what's gonna happen here?
I'm going to have a really acidic solution. I'm going to have a lot of protons in solution.
Yeah, is this going to break apart, or is this going to break apart?
The HCl.
Yeah, this H plus is going to come off Cl minus and leave Cl minus. Why is this H plus going to come off? Where's it going to go? Is it going to go to OH minus, or is it going to go to H2O?
Well, there's probably not going to be that much OH minus in solution.
Exactly. Initially, there's 10 to the negative 7th OH minuses in solution, right, in neutral water. So there's not enough to pull this H off. This H plus is going to go to the water, right? The water is actually what is going to pull that off. In other words, let me just clarify this. HCl plus water goes to H3O plus Cl minus. So where is this proton going? It's going to the water. And that's what's happening. It's not HCl plus OH minus, right, an explosive reaction. It's plus the water. So the best answer choice here is answer choice C. 13 is C. Okay, it's time for passage 3. Let me check on Jordan here. Hey, Jordan.
Yeah.
What are you doing?
I'm trying to make a flash distiller.
A flash distiller. Hey, come on, it's your turn. Let's go.
All right.
You're up.
I'm going to try this, see if it worked.
No, thanks. You do that.
All right. Let's work on passage 3. Passage 3 starts with question number 14, which says the normal boiling point of seawater is 102 degrees Celsius. Which of the following properties of the superheated seawater could explain why it enters the desalination plant in liquid phase at 120 degrees Celsius? So it normally boils at 102 degrees Celsius, but here it enters the flash distillation chamber or plant at 120 degrees Celsius, and it's not boiling. Doesn't make sense, or seemingly doesn't make sense. But in the third paragraph, it says superheated seawater enters the plant from the left end and is passed through a series of flash chambers, each held at a successively lower pressure. So what did I want? What's the point I wanted to make?
Well, there are a couple questions here. Why, at 102 degrees, first of all, why isn't it boiling? Why is it boiling at 102 and not 100?
Well, that would be because we've got boiling point elevation going on because there's salt dissolved within the water.
Yeah, exactly. So right away we know it's not due to non-volatile solutes because that's already there. That's why it boils at 102. So B must be wrong. Right? Because it's not boiling at 120 because of non-volatile solutes.
Okay.
Okay. Hydrogen bonding, I think of right away when I think of boiling point.
And we've been talking about that.
But it already is hydrogen bonding.
Okay.
Right? That's why it boils at 100 degrees and not 50 degrees. That's why water boils at 100 degrees.
Great.
So that can't be the answer.
Great. So we've got high pressure and low temperature. It's certainly not low temperature because it's well above the boiling point of water. That can't be the right answer. So it has to be C, high pressure. So I just want to talk real quickly about what's going on. Essentially, we have to remember that water, if this were a pan of water, let's say, there'd be a vapor pressure or pressure on the top of the water that is the water trying to become vaporous. And what happens is you can increase the vapor pressure by heating the water. Normally, if you had a pan of water at, say, room temperature, it's not going to just boil off. I mean, there will be some vapor pressure and there will be some molecules of water jumping off. But the reason it doesn't boil off sort of spontaneously is because there's atmospheric pressure pushing down on the surface of the water, holding the water in its liquid form. However, again, when we heat the water, what will happen to the vapor pressure of the water is that it increases until at some point it overcomes atmospheric pressure, and that's when, by definition, we reach boiling. In fact, that's a good definition.
When the two are equal, we have boiling.
Great.
Exactly.
So what's going on is, at 120 degrees, and the reason that C is the best answer for 14 is because even though we're above the boiling point of water, even of salt water here, we've increased the atmospheric pressure, or the pressure pushing down on the surface of the water, so the water stays in liquid form because it's under very high pressure here. And so that whole description is going to be important for us understanding the rest of what's going on in this passage.
So what happens is that water 120 degrees is at high pressure. It moves into the flash chamber 1, which is at 0.8 atmospheres, and suddenly the pressure is dropped, and poof.
It boils.
We get flash boiling.
And then the salt is left here, and then the fresh water condenses up here where it's a little bit cooler. We get the condensation of the water, and we get fresh water running out of the
Oh, so the 5 degrees Celsius seawater, actually, that's like a pipe that cools and allows the water to condense on the pipe, and it drips back into the fresh water.
You should see the apparatus I've got in the bathroom.
I don't think I want to.
Yeah, I don't think so either. All right, so question 15 then says, which of the following contaminants could not be removed by flash distillation? Now this question really is reading comprehension. The first sentence says many arid companies rely heavily on desalination plants. And the function then of this thing is a desalination plant, or a D for making and salination for salt, so we're removing salt. So we got to find the answer choice here, which is not a salt. Of course, ammonium oxalate would be a salt. Benzene, is that a salt?
No, benzene is not a salt.
Not a salt,
right.
So that might be a right answer. Nitric acid and sodium chloride could be defined certainly as salts. So benzene is the only one that is not a salt. We wouldn't need a desalination plant. We'd need some other way of removing benzene from water.
Right, and salts have very high boiling points. Benzene is an aromatic compound, which means it's going to have a low boiling point. So benzene is going to boil at a lower temperature than water, and the salts are going to boil at a higher temperature. So here, benzene will just boil with the water, and it won't be removed.
And never condense. Good. 16. What is the reason for maintaining successively lower pressures in each flash chamber? So again, what we're looking at here, and again, we're looking at big picture, why are we maintaining successively lower pressures in each flash chamber? And what's going on is we got the 120 degree seawater coming in, and you can see as the seawater exits over here, it's at only 85 degrees Celsius, which is below the boiling point of seawater, because we learned the boiling point of seawater under normal atmospheric conditions would be 102 degrees Celsius.
So under 1 atmosphere.
Under 1 atmosphere.
Right.
Good. So over here we've got less than 1 atmosphere and then half 1 atmosphere. So what's going to happen is the boiling point, or the temperature at which the vapor pressure will overcome, or will meet and overcome atmospheric pressure, will be less. So we're going to have to decrease the pressure here and here so that we can continue to make steam even though the water is cooling off.
Exactly. Just as we can raise the boiling point of seawater by increasing pressure, we can lower the boiling point of seawater by reducing pressure. So that's what we're doing. We're reducing pressure each time and poof, allowing flash distillation in each successive chamber.
Poof?
Poof. Right. Just like we de-un the salination. Okay.
So let's find the answer choice that says that. Again, 16, what is the main reason for maintaining successively lower pressures in each flash chamber? The best answer would be C. As the seawater cools, it requires lower pressure here and here in order to boil. So the best answer for 16 is C. 17, the cool seawater removes heat from the flash chambers by a process called, okay, so here we've got, as John noted, we've got cool seawater at 5 degrees Celsius, and it's removing heat. And we have to know a couple things about how we move heat in a physical system. One way is convection, and convection means heat movement, by definition, heat movement using a fluid. So this would be, obviously, seawater would be a fluid, and we're going to move the heat. The heat energy is going to go from the steam here, and the water is going to cool, and condense, and the heat from the steam will now heat the seawater, and presumably the temperature of the seawater will be 6 degrees Celsius or whatever as it exits. So the best answer for 17 is A. Evaporation is obviously not heat movement. That is how we cool ourselves, but that's a biological process. The others just don't make any sense in this case.
Flashing doesn't make sense. Radiation is heat transfer, but in this case, radiation isn't the best answer. As you said, convection, the seawater absorbs the energy and then carries it by a current through that pipe, and that's convection, whenever we're carrying energy via current of fluid.
Great. 18, a prototype desalination plant is built that processes 100 kilograms of seawater per second. If that seawater must be heated from 5 degrees Celsius to 120 degrees Celsius, approximately how much power is required? Assume the specific heat of seawater is 4.18. Okay, so this question is now asking us for a power. And we need to know a couple of formulas for power. One formula for power that we need to know is power. Again, what I'm doing is I'm going to try and simplify this question. I want to ask myself, what is it asking for? Clearly, it's asking for power. In this case, power would be amount of work per unit time. And the thing about this work here is that really we could define work in this case as a change in energy. And the energy change that is occurring with the heated seawater is, we can use the formula for energy, heat energy again, is Q is equal to MC delta T. Excuse me. So now let's plug this in. We've got C delta T over time, and that should give us our power, or the right answer to this question. So we've got 100 kilograms of water per second. That will be our mass, 100 kilograms per second. The C of seawater is given as 4.18. Let's just make that 4.2. And the units there are kilojoules per kilogram degrees Celsius. And the change in temperature is from 5 degrees Celsius to 120 degrees Celsius. That'll be 115 degrees of temperature change. And it's all per second. So the time here will be in 1 second. Now all we got to do is a little bit of math. We got 4 times 115 is 460 times 100 is 4.6 times 10 to the 1, 2, 3, 4 times 10 to the 4. Now the thing is, this is in 4.2 kilojoules. This is the temperature change is just in temperature. So this is 4.6 times 10 to the 4th
kilowatts.
Kilojoules, and because it's per second, that would be kilowatt. Right. Let's find the answer that says that. It would be I got 4.6, but I rounded a little bit, 4.8 times 10 to the 4th. Again, the unit would be a kilowatt because we're talking about power. Power would be a joule per second in this case, be kilowatts. Best answer for 18B.
Okay, I don't know where Jordan is. We're starting passage 4, so we're going to get started here. What are you doing? Where have you been?
Hey, I was doing empirical studies on the scientific concepts tested by passage 4.
Okay, goofing off. Let's go. Why don't you have a seat? We just started. We're on question 19.
Okay.
All right. All right, question 19. As the coffee in the thermos cools, this question is asking about the entropy and the enthalpy of the coffee. So as the coffee cools, its entropy, does it increase or decrease? Well, one thing you want to know about entropy is entropy always increases with temperature. So here the temperature is going down, so entropy is going down. So we know it's got to be C or D. Then we take a look at the enthalpy. And the definition for enthalpy is internal energy plus pressure times volume. This is the definition of enthalpy. So in this case, what's happening with the internal energy as it cools?
As it cools, internal energy is decreasing.
Exactly. The coffee is losing energy. Internal energy is the energy of the molecules, and the molecules are slowing down. And so that's the cooling of the coffee. So U is going down, and pressure and volume, pressure for a coffee is going to be about 1 atmosphere. And this is liquid coffee. It's really going to be the local atmospheric pressure, which we'll call 1 atmosphere. And the volume of the coffee is not changing significantly as it cools. So this term is not changing. So if U is going down, enthalpy must be going down as well. So choice C is correct. Entropy decreases and enthalpy decreases. Question 20. The flashlight requires 2 1.5-volt batteries placed end to end. What is the total voltage required by the flashlight? So I have a 1.5-volt battery, and I'm going to place another battery, 1.5 volts, and then they're asking me what is the total voltage from here to here, and that's going to be a total of 3 volts.
That's just definitional, and you need to know it.
Right, exactly. In fact, let me just show this one situation. What if the batteries were placed side by side? So I have a 1.5-volt battery here and a 1.5-volt battery here. What would be the total voltage across there?
In this case, it would be 1.5 total volts.
Exactly. We don't add up the voltage if they're in parallel. It'd be just the same.
Definitely. Okay. It's kind of like a larger battery this way.
Right.
As opposed to...
Okay. Question 21. Limestone has low solubility in neutral water. However, water containing carbon dioxide is slightly acidic and dissolves limestone as per the following reaction. Based on this reaction, which of the following most likely occurs during the formation of stalactites and stalagmites? Okay, I have written the reaction up here. I hope you can see it. Carbon dioxide gas is released by water as it drips from the ceiling. So if we're creating stalagmites or stalactites, what do we want to create here?
the calcium carbonate. That's
exactly,
the
the solid. That's the rock part of it. So we want the reaction to move this way. So let's see. Carbon dioxide is released by water. That means we're going to lose carbon dioxide, and if carbon dioxide comes out, then when we remove a product here, we're going to move the reaction this way, right? If we remove a compound, the reaction will move to the left.
According to Le Chatelier.
So A works. Let's take a look at B. Carbon dioxide gas is absorbed by water. That would mean we put carbon dioxide in, the reaction is going to go this way, and we're going to lose calcium carbonate.
Yeah, that would
So that doesn't work. How about C? Calcium bicarbonate precipitates as water drips from the cave ceiling. This is calcium carbonate, not calcium bicarbonate. Bicarbonate is HCO3 minus. Okay, this is CaCO3. Okay. D, solid calcium precipitates as water drips from the cave ceiling. There is no solid calcium precipitating here. This is calcium aqueous, calcium ion aqueous. So the only answer choice here is A. Number 21 is A. Question 22. The adventurers come to a precipice. They tie the rope to their backpacks and dangle the backpacks over a precipice. The mass of the middle pack is unknown. As shown in the diagram below, the backpacks are, okay, look at our answer choices, moving downwards or upwards at constant velocity, accelerating downwards or upwards. Let's take a look here. So first let's figure out if they're accelerating or if they're moving at constant velocity. 1,350 newtons, and the total weight here would be 50 and 50 and whatever this one is. Okay, this looks kind of complicated, and 90 here. How can we approach this problem? I would suggest we get rid of the variable first. We get rid of the unknown. Let's ignore this a second, and let's make our system just that section. If our system is just this section, let me move this over a little bit. If our system is just this backpack, we have a 50-kilogram backpack here. Pulling up on that 50-kilogram backpack is 1,350 newtons. Pulling down on that is 900 newtons. But there's still another force on this backpack, and that's the weight of the backpack. And the weight of the backpack is pulling downwards at
500.
mg, or 500 newtons. So the total downward force then is 1,400 newtons. That's the total downward force. Total upward force is 1,350 newtons. So what does that mean?
We've got a 50 Newton net force.
A net force downwards. So what do we know about this whole system, about this backpack?
It can't be.
It's accelerating downwards. There's a net force. F equals ma. The sum of the forces equals ma. So there's acceleration downwards. So I know if this backpack is accelerating downwards, these are accelerating downwards as well.
Oh.
So answer choice is C. 22 is C. So a tricky question, but what it is here is isolate a system. You don't have to choose the system they're giving you. Choose any system you want. I chose this one because it has this information, and this information, no unknown. If I had chosen this as my system, I would be losing this information, right? I'd have 900 M and 50K at 50 kilograms, so I could get any answer I wanted. So I chose a different system.
It's really interesting, the design of this question, too, because in the text, they say the mass of the middle pack is unknown, which directs you to think about that unknown M, and it kind of gets you thinking that way, and you have to be careful. I mean, if conceptually if you're aware of where you are in answering the question, that's really what's important, and I think your way of answering it is the best way. I mean, you have to ignore the M.
It's a tough question, exactly. So you got to focus. Don't allow MCAT to focus your attention where they want to. You have to decide. You have to decide where you want to focus your attention.
That was well said.
Okay, question number 23. Upon entering the cave, the adventurers hike 4 miles north down a slippery slope at a 30-degree angle. Then they turn and continue on level ground for 3 miles straight west. At this point, approximately how far are the adventurers from the cave entrance? Okay. Very tricky question because they've taken something that we normally think of in 2 dimensions and they've put it into 3 dimensions. So let's see if we can put it back into 2 dimensions. So upon entering the caves, the adventurers hike 4 miles north. Okay, but they're hiking at an angle of 30 degrees. 30 degrees, and they're going to hike, I'm going to call this way north, okay? But they're going down at a 30-degree angle, and that's 4 miles. Okay, so this is their path. Now they get here, and they're going to turn, if this is north, they're going to turn, which way?
Straight west.
They turn straight west. Now, west would be actually into the board. Let's just call it straight. Let's call west this way. It really won't make any difference to our problem, and I don't have to go through the wall to get to it. So they're going to come out this way. Now, when they come out this way, notice that's a 90-degree angle to the way they were walking before. Even if we're east, it would be a 90-degree angle, right? So now I have down and a 90-degree angle this way. And how far do they walk there? They walk 3 miles this way. Okay. So basically, they're going to walk 4 miles, turn a 90 degrees, and go 3 miles. Let me redraw that. 4 miles, turn 90 degrees, and go 3 miles. And now the question asks, at this point, how far are the adventurers from the cave entrance? Here's the cave entrance, so the question is asking, what is X? Do you recognize something here?
It's a 3, 4, 5 triangle.
It's simply a 3, 4, 5 triangle. Not only that, you should look for these numbers, 3, 4, 5, because they're big on MCAT. So it's just a 3, 4, 5 triangle. Question 23, answer choice is B.
So again, there was all this extraneous information meant to mislead us and misdirect us. And frankly, a lot of my students, I've seen that. They struggle with that. They say, well, what about the slippery slope and the 30-degree angle? And it's as simple as that.
This 30-degree angle didn't do anything. You just have to, and notice something else. Drawing a picture helps.
Absolutely.
Right? And just, okay, if I'm going east, if I'm going north and I turn east, it's
west.
90 degrees. Or west, it's 90 degrees. Okay. Right, question 24. Medium-sized falling rocks could easily shatter the plastic helmets of the adventurers. Nevertheless, the helmets offer the adventurers adequate protection from the medium-sized rocks. The shattering of the helmets protects the heads of the adventurers by, okay, what are our choices? Absorbing or redirecting energy, decreasing or increasing impulse. All right, let's take a look at the absorbing or redirecting energy. Can you redirect energy? You can't, because energy is not a vector, energy is a scalar. Energy doesn't have a direction. So B makes no sense at all. You can't redirect energy. All right, can you absorb energy? You can, and when that rock hits that helmet and the helmet shatters, the energy, the kinetic energy of the rock is absorbed by the shattering of the helmet. The rock does work on the helmet, and that way doesn't do work on the adventurer's head. Okay, so A is correct answer. And C, decreasing the impulse or increasing the impulse of the collision. The impulse of the collision is going to be conserved, right? Because the momentum is conserved. So you won't increase or decrease the impulse by the helmet will not increase or decrease the impulse. So best answer here is choice A. Number 24 is A.
Right, and you might see that particular question in another variation. For example, they design race cars to break apart if they hit a wall. So you may have seen a race car on TV smash into a wall and then pieces come flying off. What are they trying to do? They're trying to somehow dissipate that kinetic energy in that race car. So
exactly, that energy, the kinetic energy of that race car is going to go somewhere. And what we don't want to do is put it into the driver and make him absorb it. So when the car collides, boom, it shatters, and now this door has kinetic energy. That had to come from somewhere. This flying tire has energy, came from somewhere. It came from the energy of the collision, and that way the energy doesn't go into the driver. Otherwise, the energy goes into the driver, and his bones break and absorb that energy.
You wouldn't have too many race drivers, would you?
No.
Not doing it, thanks.
Okay.
All right. Let's look at the first set of freestanding questions, starting with question number 25. It says, when A and B are connected in the circuit below, when A and B here are connected, which of the following gives the voltage across the capacitor as a function of time? There's only a couple things you have to know about capacitors. One, their function is to store charge, and two, at some maximum, if this is a 12-volt battery in this circuit, the total voltage across this capacitor at its fully charged state will equal the voltage from this battery. In other words, when it's fully charged, the voltage across here is going to be 12 volts. So let's find out.
But that's in this particular circuit.
Right, because we've got...
If we put another resistor in there, we'd be different.
It could make it different. Great. So we've got a 12-volt max. That's going to eliminate answer choices C and D as possible answer choices. We're down to A and B. Now, what's going to happen is as this capacitor stores charge, we've got the positive terminus of the battery over here. We're going to build up a positive charge on this plate and a negative charge on this plate, over time. And what will happen is initially those charges will collect here fairly rapidly. But as we build a positive charge over here, any incoming positive charge from the incoming current is going to come in slower and slower. So the graph will have us going up fairly rapidly, and then over time we'll level off, and at some point we'll reach our maximum of 12 volts. So the best answer choice for this particular question is answer choice B. And I would definitely memorize the structure, the shape of this graph. I would understand that as
I think
a
that's
charge
the best way to do it. May I point something out on
Absolutely.
this graph? One thing you can look at, in this battery defines the voltage. So the voltage here is 0, the voltage here is 12. Voltage can only change across a circuit element. So as we go here, this is all 12 volts, all this, all the way to here, 12 volts, because there's no circuit element. And all the way around here, this must be at 12 volts, because there's no circuit element. Over here it's 0, because this is the battery. It defines 0, 12. So it's 0, 0, 0, all the way around here to here, it's 0. So this is 0, this is 12, 12 volts. 0, 0, 0, 0, 0 here, 12 here, so it's 12 volts.
Great. Thanks, John. Good. Let's go to the next question. It's 26. It says the electron configuration of magnesium 2+ is. And so we got to bring out our periodic table, put this chart up, put this graph down. And here's our periodic table. And we're looking at Mg2+. Obviously, if we're looking at Mg2+, we've taken 2 electrons away from the magnesium atom. If we take 2 electrons away from it, its electron configuration is going to be similar to that of neon. So we got to find the answer choice that says that. Unfortunately, none of these answer choices say neon exactly, so we have to find the one that would be the equivalent of neon, and that would be answer choice A. It would be He plus 2s2 2p6 would be neon. So the best answer for question 26 is A. You need to be able to solve that problem out. If you had some trouble with it, you need to look at that and maybe practice with a couple of different atoms in their ionic form and figure out what their
electron configuration should be gimmies. You should have that with no problem. So just practice electron configurations.
Good. 27. Which of the following describes the change in enthalpy and entropy when forming ice? Now this question is similar to the question that we saw in one of the recent passages about the coffee that was cooling. In this case, however, we're forming ice. And what we can do is we can draw our phase change diagram up. And we have a 5-sloped diagram that looks like this. On the vertical axis here will be temperature, and on the horizontal axis here will be heat energy added. Right? And so at the very lowest temperature, obviously we're going to have the solid form of whatever substance we're talking about. We've got phase change liquid. Now the thing is, when we're talking about freezing ice, we're going from the liquid form here, let me just write in liquid, of the ice, and we're removing heat energy, or we're giving heat energy off to the environment as the liquid cools and becomes solid. So we're going in this direction. Temperature doesn't necessarily have to drop. We're just freezing the water. So definitely heat energy is going off into the environment. In other words, we can eliminate a couple of answer choices. Enthalpy certainly has to be negative. B says enthalpy change is positive. That couldn't be right. And C says enthalpy is positive. That couldn't be right. So now we've got to decide, well, what happened to entropy? And of course, entropy is what, John? Entropy is
a measure of disorder.
Is disorder. So what's going to be more disordered? Ice or solid water, or water liquid?
Liquid water is more disordered.
More
so
disordered.
Greater entropy.
So as we go from solid to liquid, we'd have greater entropy. So as we go from liquid to solid, less disorder, less entropy.
So negative change in entropy.
Negative change, making answer choice D the best answer for 27.
Notice that the tricky thing here is we're going, or for me anyway, we're going from water to ice. We're making ice and we're giving heat off.
Right.
And that seems contradictory, but that's actually what happens. The water molecules are moving all over the place in water, and then as they become ice, they stop moving. They become a rigid structure and start vibrating. So they lose some of that energy. The energy has to go somewhere. It goes to the environment. And so we actually do give heat off when we make ice.
You know what I'm thinking? If you really struggle with that, think about, you wouldn't, if you drink a Pepsi or a Coke or a soda, you put ice into it because you want to cool the soda. Well, that's because the ice is absorbing the energy. So that would be essentially the reverse reaction. Here we're making ice, so the energy has to be released from. Good, so 27 is D.
Okay, let's move to question 28.
All right.
What is the concentration of hydrogen ions in solution when 100 milliliters of 0.1 molar HCl are mixed with 300 milliliters of 0.2 molar NaCl solution?
Okay, this is kind of a question where a lot of students might be confused by it because they're a little intimidated maybe by the acid-base thing going on, and they start assuming. And really, if you look at it, it breaks down to some pretty simple math. We just got to know how to set the problem up. So we've got 100 mils of 0.1 molar hydrochloric acid solution. And of course, hydrochloric acid, being a strong acid, is going to just dissociate completely. So what's going to happen is this is going to result in us having a certain amount of hydrogen ion dissolved in solution. And we can calculate that. If we have 0.1 molar HCl, that would mean we'd have 0.1 moles hydrogen in solution in every 1 liter of water. But in this case, we only have 100 milliliters, or 1/10 of a liter. So we only have 1/10 of 0.1 moles total H+. So our number now is 1/10 of 0.1, or 1 times 10 to the minus 2 H+ ions in solution. We've got 1 times 10 to the minus 2 moles of H+ ion in solution.
In 100 milliliters. Exactly.
In our 100 milliliter solution. And now what happens is we add 300 mils of 0.2 molar sodium chloride solution. And the thing about sodium chloride, of course, is that it's not going to affect the H+ concentration in solution.
Because it's a neutral solution, so it doesn't change the H+ concentration. You can ignore that.
Yeah.
It's like adding pure water.
It is like adding pure water. And the only thing that's important then about it is that in addition to the sodium chloride, we do add around 300 mils of that water. So now we've still got our 1 times 10 to the minus 2 moles of H+ ion in solution, but now our total solution is a 400 milliliter solution. So let's just do a little math here. We've got 400 milliliters, which is 4 times 10 to the minus 1 liters. If we do a math here, 1 over 4 is 0.25. 10 to the minus 2 over 10 to the minus 1 is 10 to the minus 1. We can move this over 1. We've got 2.5 times 10 to the minus 2.
Which is answer choice C.
Easy as pie. So you can see it's really kind of simple math once we know how to set it up the right way. You got to read the question very carefully in this case, and you got to, as John said, sodium and chloride they're not going to affect the concentration of H+. It's like adding pure water. So 2.5 times 10 to the minus 2, question 28 is C. Let's just go ahead. John, you mind if I take this next passage?
Go ahead. This passage fine.
Excellent. This next passage, kind of an interesting passage. It's got things called collimating slits. You don't obviously have to know much about collimating slits going into the MCAT, but we got to be able to figure some stuff out here. Let's just go ahead and jump to question 29, being the first question. It says, if O2 gas had been used instead of N2 gas, how would the plots for the 3 temperatures shown in figure 2 have changed? So let's go ahead and put figure 2 up here. Let's think about what we have to know here. We got figure 2 from the passage, and it says, this question says, if we use O2 gas instead of N2 gas, what's going to happen? Essentially, that's the question. Now, the thing about this, and we have to remember Graham's laws that relate the velocity, the relative average velocities of these two gases and their masses. And oversimplifying here, what we can say is that the more massive particle is going to move slower. So we look at this, obviously the molecular weight of oxygen gas is going to be 32, and the molecular weight of nitrogen gas is going to be 30, making the oxygen gas more massive.
28, right, for N2?
For N2, thank you. Of course it is 28. This is more massive, which means it's going to go more slowly. Its velocity will diminish. So we look at our graph then, the graph which displays information for N2 gas. If we're displaying O2 gas, which is more massive and slower, the speed here is going to be less for the O2 gas.
So all the peaks are going to shift over.
Right. The peaks at every temperature are going to shift a little bit to the left because it's more massive, it'll move slower at any temperature.
Answer choice A, the peaks will be shifted to the left.
The only one that works.
Okay.
Great. So question 30. After measuring the speed of the N2 gas molecules at a temperature of 0 degrees Celsius, what changes should be made to the synchronized disks in order to measure their speed at 1,000 degrees Celsius? So what's going on is now we're going to use this diagram. And this question, when I read through it, there's a lot of text there, and it may be a little confusing as to what's going on. We're looking for changes that should be made to the synchronized disks in order to measure the speed at 1,000 degrees Celsius. So we've heated the N2 gas. As we heat it, what's going to happen? Is it going to move faster or slower?
It's going to move faster. We're adding energy.
It's going to move faster. So the question is, what do we have to do to these synchronized disks when the gases are now moving faster? Okay, so what I like to do on this particular question is first conceptualize a little bit, right? If you heat a gas up, let's imagine I'm a gas, right? First I'm going to move kind of slowly. So here I am at 0 degrees Celsius, I'm an M2 molecule, moving kind of slowly. And if you think about that, let's just look at a faster moving N2 molecule. It's going to go really fast, right? Now we got to think about how those two situations might affect our collimating slits. Obviously, and let's compare that to our answer choices. A says the speed of the disks should be decreased or the distance between them shortened. So those are the two variables. We got the speed of the disks and the distance between them, right? So let's consider, I guess, first the distance between them, because that one might be easier to get our heads around conceptually. Again, the slow-moving gas, those two slits here have to line up perfectly. They have to line up perfectly so the gas can get through both to the detector. So slow-moving gas, we'd have to put them really close together, so that slow-moving gas might be able to move through both. We speed that gas up, we can move the disks further apart, and that faster-moving gas can get through both at the same time. So as we speed the gas up, it may be able to get through a longer distance.
So we can spread the rotating disks because it takes a shorter time to go from one disk to the other. And if they're turning at the same rate, we got to spread them out to allow that greater length.
Great. So A and B both say when we heat up the gas, we need to shorten the distance. Those two answers can't be right because those would be shortening the distance. That doesn't make sense. So we're down to C and D. And so now the other thing that we're looking at is the speed at which they're rotating, right? Now the speed at which they're rotating, as we speed it up, it's going to be more and more difficult to make it through both together. And if I'm a slow-moving gas, I may make it through this first disk, and then this second disk, if it's moving pretty fast, I'm going to smash into it. I'm not going to get through the slit. So the faster I move, the faster then can these slits be moving, and I can get through both together. Now let's find the answer choice that says that. D says the speed of the disks should be increased or the distance between them lengthened. So the best answer to this one is D. And in my mind, the best way to answer this question is to conceptualize, and you can see that I'm doing a little bit of exaggeration and a little bit of trying to make it real world so I can touch it. And in my mind, you see a question like this, it's intimidating, it's a little bit confusing because there's extra information. We like to draw diagrams, but another thing you can do is just make it conceptual.
Good.
Cool. Question 31 then. Equal volumes of H2 gas and O2 gas are compared at the same temperature. Which of the following statements is true concerning this comparison? Okay, so we've got equal volumes. And of course, one of the things we have to know about equal volumes is we have equal volumes, they're both gases. Even though the O2 gas is going to be significantly larger, the molecule itself is going to be significantly larger than the H2 gas, the volume that a similar quantity would occupy is going to be the same.
Well, no, they tell us equal volumes.
Okay.
Right? That's the question tells us. That's important. If we look here, we've got pressure, volume, and temperature, the three possible variations. They tell us the volumes are the same, and they tell us the temperature is the same. However, the pressure could be changed. So if we take a look at A, the number of molecules in each gas must be the same. That's not true because we could change the pressure. If we write PV equals nRT on the board, for instance. Mm-hmm. So what can we change here? R is a constant. They told us volume and temperature are the same. Mm-hmm. So we can change, if just because volume and temperature are the same, the number of molecules could be different, and that would change the pressure. So A is wrong.
Okay.
B, the pressure of the two gases must be the same. Well, that's wrong as well for the same reasons as A, because we could change the number of molecules. C, the speed of any H2 molecule will be greater than the speed of any O2 molecule.
That's a good trap answer.
That's a trick one.
Yeah. And what's going on there is we assume, and because of Graham's laws or because of our comparison of mass to volume, because this one's more massive, on average, it should be moving slower. But the problem with answer choice C is that the speed of any H2 gas molecule will be greater than the speed of any O2 molecule. Well, think about it. If one of those H2 molecules hits into the wall, at that instant in time, what's its velocity when it hits that wall? 0. It hit the wall. It has stopped in that instant in time. So obviously there will be O2 molecules within that container that are moving faster than that one. So any and any in this case makes that a wrong answer.
Right. The speed that we're talking about usually is the average speed, but here they're saying for any given molecule. And at any time, no matter what the temperature is, you have some molecules that are moving very slowly, some molecules that are moving very fast for any given sample.
Great, but so D really describes the rule as we have to know it, and it's phrased actually pretty well. The molecules of H2 gas will have the same average kinetic energy as the molecules of any O2 gas. The kinetic energy in a gas is proportional to temperature, and you should understand that. It's one of the tenets of the ideal gas law. D is the best answer.
And the equation is Ke equals 3/2 RT. You want to write that up, Zil?
Ke of a gas.
Right. The kinetic energy, the average kinetic energy of any gas is proportional to the temperature, and this is the equation that we use.
Great. Thanks for the pickup, John. Great. So question 32. A molecule of N2 gas has a mass of 4.65 times 10 to the minus 26 kilograms. What is the VRMS of N2 at 0 degrees Celsius? So, of course, this is going to impart a lot of math. If you got to set up the math.
Square velocity is, by the way, is VRMS. Now, what are you doing?
I'm just going to do the math, man. Go ahead.
No.
Just take a break.
Remember, this is MCAT. I think you've forgotten. This is an MCAT question.
Okay.
In MCAT questions, we're always looking for
the simplest way.
The simplest way. So before I start taking 4.65 times 10 to the negative 26, plugging into all that equation that they give us in the passage, is there an easier way to find they're asking me the root mean square velocity, or the average speed, basically the average speed of these molecules at 0 degrees Celsius?
Let's see.
Let's see. We got it right there. 0 degrees Celsius. What is the average speed of the molecules in that hump? It's going to be the peak there, and it's going to be about 500. Look at the answer choices.
There's only one. There's only one that's even close to 500. And what's going on? Again, 0 degrees Celsius. The average speed of these molecules is going to be 500. If you fell into the trap of doing the math, don't feel bad about it. Again, and learn something from it. What you should learn is you didn't do it the simple way, right? And this is a very clear example. This particular question is, if you went to math, you're not thinking about, you're not always going back to how do I do it simply.
Right, here you actually could solve it by using the math and the equation, but you're going to spend
a good
some
long
time.
Yeah.
Exactly.
All right, so question 33. The pressure of 1 mole of N2 in a 22.4 liter container is... Okay, so obviously one of the factoids that we have to memorize for the MCAT is that 1 mole of any gas occupies 22.4 liters
wait, again,
at STP.
Before you start doing that, let's look at the answer choices first. Because before we start, 22.4 makes us think, okay, now we got to remember STP. Let me start thinking about all that stuff. But look at all the information the question gives you. Greatest at 0, greatest at 100, greatest at 200, the same at all temperatures. We don't care about 22.4 liters. We don't care about 1 mole. They ask us the pressure is greatest when? The pressure is greatest at the highest temperature.
Which we should know from our ideal gas law. As we increase temperature, holding other values constant, pressure has to increase. The question is, the pressure is greatest at what temperature? At the highest temperature. Only one that makes sense is...
Right. Make sure when you're doing an MCAT question, you go to the simplest answer first. Think about the simple way to solve the problem first. That's reading all the answer choices, and then ask yourself, what's the easiest way to answer this? Maybe the easiest way won't work. Go to the next easiest, and then the next easiest, because the easiest way is the fastest.
Right, and if you're worried about, that's going to take me a lot of time to figure out the easy way, well, think about it. I mean, on that last problem where if you did the math, all you got to do is the fast way on a couple of problems, and you'll have economized greatly and not spent as much time as you could do doing the math on that one problem. So especially if you're struggling to finish, I mean, you just got to find that simple way. Good. All right, welcome to passage 6. In an effort to investigate the relationship between mechanical energy and heat, I'm going to heat up the water in this bottle, and we'll measure the temperature increase. And hey, do you have a thermometer?
No. Let's just go ahead and do the passage.
Maybe I'll just drink some warm water.
All right, passage 6. Passage 6, question 34. When the aluminum pellets sink to the bottom of the test tube, what energy conversion has taken place? All right, let's look at this passage a little bit first. We've got this test tube here, and we're putting aluminum pellets up here, and we're allowing these pellets to sink to the bottom, turning it over, allowing them to sink again. So how does that apparently heats up the water. So how is that heating up the water? Well, these pellets have a certain amount of energy when they're at the top, and that energy that the pellets have is equal to their potential energy, MGH. As they fall through the water, they collide with water molecules, causing those water molecules to move faster. When the water molecules move faster, that is heating up the water. So this MGH is being converted to heat energy of the water. Then I turn it over, and notice when I turn over the test tube, I'm doing work on the test tube because I'm bringing those pellets back up to the top. I'm giving them back energy, and the pellets fall through again. Each time I turn the thing over, the water heats up a little bit more. Okay, so when the aluminum test tube pellets sink to the bottom of the test tube, what energy conversion is taking place?
It's got to be big.
Yeah, we're going from potential energy, which is a type of mechanical, right? Mechanical is potential plus kinetic. So we're going from potential energy to heat. It's heat energy of the water. So choice B is correct.
Yeah, I'm just looking at the to heat part, and that's what the passage is about. That's the only one that says to heat.
That's the easy way, exactly. Yeah. The easy way, just very good. Okay, question 35. Which of the following would increase the temperature difference between each inversion? So let's take a look. Using a larger test tube. Well, a larger test tube, at first you might think, well, yeah, it'd be taller this way. I'd get greater potential energy. But it doesn't specify taller. Also, if it were taller, I've got more water. So actually that wouldn't, even if I just lengthened it. If I widened it, I've still got more water, and then I don't even have more energy to compensate for that. So that doesn't work.
In my experience, that's the one that most students choose. They go, oh, that's got to be the right answer.
Right, but when you're adding more water needs to be heated, so it doesn't increase it. Conducting the experiment without the aluminum foil and plastic bag. Well, the aluminum foil and the plastic bag act as insulation, keeping the energy in the water and not allowing it to escape out to the environment. So that's actually, if we didn't use that, it's actually going to cool the water. So that won't work either. Shortening the time between inversions. That doesn't increase the amount of energy for each inversion. That would make the water heat faster, right, because I'm doing more work faster, but the question asks about each inversion, so C doesn't work. Using heavier pellets. If I increased M, the amount of energy that goes into the water is going to increase. That's going to increase the temperature. So D is correct for 35. Okay, question 36. If the total mass of the aluminum pellets is 45 grams, how much potential energy do they lose each time they sink to the opposite end of the test tube? Well, they're going to lose all their potential energy, right, which is mgh. So the total mass is 45 grams. Let's not forget to change that to kilograms. So 0.045 kilograms times 10 meters per second squared, that's G, times the height, which is 10 centimeters. 10 centimeters is 10 to the negative 1 meters. So I have 4.5 times 10 to the negative 2 kilograms times 10 to the negative 1. So I end up with 0.045 joules.
Answer choice B.
Answer choice B. Question 37. The student considered using lead pellets rather than aluminum. What effect would using lead pellets have had on the rate at which the pellets fall through the water? All right, so what's the difference between lead and aluminum? And they tell us there it's the density. And so lead is going to have a greater density. It's going to be heavier. When we look at a pellet here, and it's underwater, what are the forces on the pellet?
Downward force is gravity.
There's gravity. There's the buoyant force, which is going to be rho Vg, which is the volume of the pellet. The volume's going to be the same for both lead and aluminum, but rho is greater for lead. I'm sorry, no. The buoyant force is, the rho is not lead, right? It is
the water.
The water, exactly. So don't make that mistake. And then there's also a drag on the pellets, and that's an upward force. And the drag is based on the speed of the pellet, and it's also based more on the shape and the size of the pellet. Okay, so what's going to be different here? This is going to be the same for both. The drag is going to be the same for both, more or less. But mg is going to be greater for the lead pellet. So expect the force downward to be greater for the lead pellet, so it's going to accelerate faster. Answer choice A. The lead pellets would have taken less time to fall the length of the tube. Question 38. The student used the data to try to compute a value for the specific heat of water. In doing this, she assumed that all the gravitational potential energy of the pellets was used to increase the temperature of the water. The value of the specific heat computed by the student was most likely. So if we look at this, what's happening, these pellets are falling down, and we already established that they're transferring their energy to the water. But we use insulation around this tube. Why?
Prevent heat loss.
Exactly. So there apparently is heat loss. And so not all this energy is going to heating the water. Some of it is being lost. So we're losing energy from this to the surroundings. Also, the pellets don't transmit all this MGH to the water because they strike the bottom with some kinetic energy. And when they do, that energy goes to the test tube and out again. So those are two reasons why she can't use all of MGH and still be accurate. Okay, so right here we have two sides to each answer choice, too low or too high, and then an explanation. Since I've just established an explanation, I'm going to ignore too low and too high for a minute. See if I can get the answer just by the explanation. So is there an explanation here? And answer choice C is exactly my explanation. Since the students neglected both the heat loss to the environment and the energy dissipated when the pellets hit the bottom of the test tube. That's exactly the explanation we had, so I would go ahead and pick C and move on, and C is the right answer. But let's just go ahead and figure out whether it's too low or too high. Now we actually know it's too high because C is the right answer. But what is she doing? She's taking this energy and she's setting that energy equal to the heat that goes into the water, which is MC delta T. So she's going to set MGH equal to MC delta T. But remember what we said is all of this M, by the way, this M we'll call MX, this M, MY, because they're two different M's. All of this MGH, she says, is going into the water. We established it's not. It's going in, some of it's going into the environment. So her MGH figure, this is really too high. And this she measured and this she measured. So C is going to be calculated too high. Okay. Question 39. Wondering about how a change in gravity would affect her experiment, the student imagined repeating her experiment on the moon. What result could she expect from this imaginary experiment? All right, so she's on the moon. We've got MGH equals MC delta T. So what's going to be different in these variables?
Well, the mass of the pellets will stay the same.
The mass of the pellets is the same.
Presumably the height of the test tube would stay the same.
The height of the test tube is the same, but G is going to go down on the moon, right? In other words, she's not going to have, each time I turn the test tube over, I don't have to do as much work because G is less. So there's less energy in those pellets and they fall to the bottom. So what am I going to have to do to get the temperature to change just as much?
Turn them more.
I'm going to have to turn it more. I'm going to have to do just as much work because each turn is less work because the pellets don't weigh as much even though they have the same mass. So I'll do more inversions. That is answer choice A. The student would have to invert the test tube more times to achieve the same temperature increase.
All right, we're looking at passage number 7. In passage number 7, I have to confess a fondness for passage 7. It is a favorite passage of mine. And it's a favorite based on the science that's being displayed. And what's interesting to me is, it's fairly simple science, and what it really does is it puts you through the paces a little bit, because if you can get through this passage, if you can understand our explanation of it today, you're going to be okay. You should be pretty okay in terms of density, buoyant force, and a couple of other factors that we're going to relate. So let's look at the first question. It says, 40 says, the tension is greatest for the string holding which balloon? So we got 3 balloons at the bottom of a 10-meter pool. We got balloon X, Y, and Z. Each one holds a different gas. And then there's going to be a tension in the string holding each to the bottom. And that should make sense because if you think about it, if you took, like, for example, a beach ball and you put it in the bottom of the swimming pool, you wouldn't be able to hold it there. That beach ball, because it's lighter or less dense than the surrounding liquid, is going to want to go to the surface. There's a buoyant force that's going to push up rather strongly on that beach ball. Well, the same thing is true of each one of these gas-filled balloons. They're less dense, presumably, than the liquid, and so the tension in the string is going to hold each one of them to the bottom of the pool. Now, they give us a little bit of a clue in the third paragraph, and we got to do a little detective work. They tell us in the third paragraph that balloon X is filled with helium. And we need to know, and we could consult our periodic table if we needed to, that the mass number of helium is 4. There's 2 protons, 2 neutrons. Helium is a mass of 4. The next sentence says the gas in balloon X has a density twice that of as the gas in balloon Y. Now, of course, density is a mass per unit volume. It tells us in the passage that all 3 balloons have the same volume. So if the density of this balloon is twice that of this balloon, that must mean that the mass of this balloon, because the volumes are constant for both, that must mean that the mass of this balloon is twice that of that balloon. The mass here is 4. The mass here must be 2. The only gas that I know of that has a mass of 2 is going to be hydrogen gas. It'll be H2 with a mass, of course, of 2.
Now, one thing you have to realize is that also means you have the same number of molecules in X as Y. And how do we know that? Because the pressure is the same throughout.
Perfect. Good. So the next sentence then said the molecules in balloon Y have an RMS velocity 4 times greater than the molecules in balloon Z. These molecules within this balloon are moving 4 times as fast on average as molecules within that balloon. And what's going on there is, from Graham's laws, we get a comparison again of the masses, the relative masses of the gases in these two balloons and their velocities. And remember that formula says that if the average velocity of these is 4 times as great as these, then the mass of this has to be 4 squared times as great as this. And so let's just write that formula up here. V1 over V2 is equal to the square root of M2 over the square root of M1.
Graham's law.
Graham's law. So there's a relationship between the relative masses of these gases and their relative velocities dictated by this law. The velocity here is 4 times as great as the velocity here, meaning the mass here must be 16 times as great as the mass here. This mass is 2. This mass must be 32. Great. So now let's see if we can solve some of these problems. 40 says the tension is greatest for the string holding which balloon? Well, if we look at each one of these balloons, we could draw a free body diagram for each one of these balloons, and we could describe all of the forces acting on the balloon. Of course, because they're near the surface of the Earth, there will be a downward force, mg, due to gravity. There will be an upward force, which will be buoyant force, F sub b. And let's do that formulaically. You must know that the formula for buoyant force is rho, the density of the water, times v, the volume of water displaced, times g. And the thing about this is F sub b for each balloon, because the density of the water stays constant and the volume displaced is constant. This value here, the buoyant force on all balloons, is the same. So we got the downward forces then is mg, and the other downward force is tension. This question asks, where is the tension the greatest? So these are all the forces acting on it. The tension must be greatest in the balloon with the smallest weight force, right? Which one has the smallest weight force? Obviously, H2 gas here is less than this and less than this. It's got the smallest downward weight, so it must have the highest tension.
Okay, so for each balloon, we could have the equation rho Vg equals mg plus t.
Okay.
And I see. So then mg, as mg gets smaller, t must get larger.
Exactly.
Okay.
This is a constant. As this gets smaller, this must get larger.
So balloon Y.
Balloon Y has got the smallest mass. If it has the smallest mass, it has the smallest weight. It must have the highest tension in that string holding it down.
Choice B. Good.
Great. So 40 is B. 41. What are the identities of the gases in balloons Y and Z, respectively? Now, we did a little bit of detective work on the last problem, or setting up for the last problem, where we determined the gas in balloon Y is H2 gas. Let's see if we can...
so that's C or D.
C or D automatically. A and B have to be out. And now it's a question of which of those two gases, N2 or O2, has an atomic mass of 32.
And that's O2.
It has to be O2, because 28 would be the atomic mass of N2 gas. Best answer for 41 then is D. Great. Question 42 then. Compared to the buoyant force on balloon X, the buoyant force on balloon Y, well, we've already really done this problem. We determined that because the density and volume doesn't change, of course gravity's not going to change, that the buoyant force on both balloons is the same.
And again, density there is the density of the water, the surrounding fluid, not the density of the fluid. Exactly.
Right, exactly.
Of displaced fluid.
Yeah, this density is key to remember that this density is the displaced fluid, not the fluid within the balloon. Great. So 42, the best answer is B. The buoyant force is the same. 43, the pressure of the gas in balloon Y is approximately. Now what's going on here is we've got a system, it's a tank system, where the balloons are all 10 meters deep within water, and we're open or exposed to the atmosphere. So at the surface of the water, we'd have 1 atmosphere of pressure working down on the top of us. At 10 meters depth, and this is a number that I'd have in my mind as I'd memorize this number, every 10 meters deep we go in water, we have an additional atmosphere of pressure working upon us. So 1 atmosphere at the surface would be 2 atmospheres at a depth of 10 meters. Another way of expressing 1 atmosphere of pressure is 10 to the 5th pascals, or 100,000 pascals. So if this is 1 atmosphere or 100,000 pascals, this must be 2 atmospheres, or 2 times 10 to the 5th pascals, 200,000 pascals. Answer choice C.
Right, and pointing out one thing, the balloons have the same pressure as the water surrounding them, and that's what gives them their shape and form.
Great, thanks. Good. 44. If balloon Z, which again is at 2 atmospheres pressure, were to float to the top, its volume would. Okay, so now what's going on is, here's balloon Z filled with 2 atmospheres. The pressure within balloon Z is 2 atmospheres. If it were allowed to float to the top, now it's no longer under 2 atmospheres of pressure, it's only under 1 atmosphere of pressure. So if we look at what happens there, PV equals nRT, from our ideal gas law, we'll assume the temperature, and R certainly remains constant. The balloon is closed, so the number of moles of gas will stay constant. What's going on is the pressure on the balloon as we go from here to here diminishes, so the volume of the balloon has to increase. Those two are inversely proportional. As this decreases, this has to increase by a like amount. The pressure diminishes by half. The volume must increase, must double. Let's find the answer that says that. 44 is C. I love it when they work out.
Good, and you know 44 is a proportions problem because of the way the answer choices are given, right? Decreased by a factor of 2, a factor of 4, so on.
Cool. 45. Which of the following most accurately represents a comparison of the average kinetic energies of the molecules for each gas? And this is definitional. I think we've talked about it already in this test. Average kinetic energy for a gas is based or proportional to its temperature, and we listed a formula for that. Kinetic energy.
And what was that formula again?
It was kinetic energy of a gas is equal to 3/2 R times T. R is a constant value. T is the temperature of the gas. So the temperature of any gas dictates its kinetic energy. So all 3 gases at the same temperature are going to have the same kinetic energy. By definition, answer choice D is the best for 45.
Good. Okay, passage 8, question number 46. Now, this looks complicated, but it's actually not too complicated. There's a little bit of reading comp in here, and we understand it a little bit, it's not too tough. 46, when the stylus is writing in black, the chemical reaction at the stylus is, now it tells us in the passage, the last sentence, iodine turns starch black. So if we look at the relevant half reactions, we see that we want iodine to be formed here. We want the reaction going in this direction. Okay. If we take a look at the answer choices in 46, we see that's answer choice D. And even simpler than that, if iodine turns starch black, we have to create iodine. The only answer choice that's creating iodine here is choice D.
Yeah, and there's another clue in the passage. It says the paper sandwich is soaked with an aqueous solution containing potassium iodide. So you're starting with presumably the ion form of
Good point, yeah, the I minus, so we're going to move in this direction. And what happens is the battery actually forces this reaction, forces it in that direction. Okay. All right, question 47. Which of the following is true when the stylus is writing in pink? All right, when the stylus is writing in pink, it says from the last paragraph, phenolphthalein turns pink in basic solution. So again, if we take a look at this reaction, if the stylus is writing in pink, this reaction is going in this direction. Okay, so what are my possible choices? Reduction is taking place at the stylus, and the stylus is the anode. Well, we know that's wrong because reduction takes place where, Jordan?
At the cathode, always.
Always. Red cat and ox. Reduction takes place at the cathode, and oxidation at the anode.
You know, John, for that reason, we could eliminate answer choice D2. It says oxidation is taking place at the stylus, and the stylus is the cathode. Can't happen. Oxidation only occurs at the anode.
Exactly. So we've got A or D. And remember, we want this reaction, and this reaction is what at the stylus? We're gaining an electron here. Gaining electron is?
Reduction.
Reduction. So answer choice C is correct. Reduction is taking place at the stylus, and the stylus is the cathode in this reaction. Okay, question 48. If the orientation of the battery is reversed, well, if the battery just forces electrons in one direction or the other. In this case, the current is going like this, so electrons are moving in the opposite direction. If I reverse the polarity of the battery, electrons will move in the opposite direction. And when they move in the opposite direction, we can see by this reaction, we just force the electron, we just change the direction of the reactions at each side. So answer choice here, the color of the writing will switch sides.
Yeah, if you look at the sandwich, the top and bottom page in the sandwich are both filter paper, and all we're doing is connecting the circuit. So the filter paper is going to be...
Exactly. The whole thing is actually soaked in the solution, and the battery just forces electrons in one direction or another. Just to understand this a little better, what's happening is we're reversing this reaction. So we've got, at one stylus, we've got this reaction going. At the other electrode, we've got this reaction moving. Now, if we reverse the battery, we just switch the reactions at either terminus. Okay. Number 49. What is the potential of the cell made by the stylus and the metal foil under standard conditions? All right, so if we take a look at the potential, this reaction we want going this way, this reaction we want going this way. So we have black writing on one end, we have pink on the other. So if when we reverse this reaction, we have to change the sign of the EMF. So this is negative 0.54. So negative 0.83 plus negative 0.54 gives me negative 1.37. Answer choice A is correct.
Right, here you have to have an oxidation and a reduction reaction happening at the same time, so we definitely have to reverse one of these. And to me, a clue is if we look at the other diagram, you've got a battery in there, which to me would indicate not galvanic and not spontaneous. So there's no way that's going to have a positive electromotive force, so answer choices C and D would have to be wrong. And then when we reverse the upper reaction here, you'd get a negative value for both these. And
right, it's less likely it's going to have a positive electromotive force. But yeah, I agree with you. It's the battery is really forcing the reaction. Okay, 12 volts will overcome this small voltage here. Okay, second set of standalones. Question 50. What is the approximate density of a 22.4 gram sample of hydrogen gas at 0 degrees Celsius and 1 atmosphere? Couple things in this question right away. 22.4 gram sample. I'm thinking about that 22.4 liters, but this says 22.4 grams. So I'll just keep that in mind. 0 degrees Celsius, 1 atmosphere, that is STP. So I'm going to think about that as well. So what's the density of a 22.4 gram sample of hydrogen gas? Now, what do I know about standard STP?
1 mole of any gas will occupy 22.4.
Exactly. I know 22.4 liters. So if they tell me I've got...
What I got to do is calculate the number of moles of H2 gas I've got here.
Right. Density is going to be mass over volume, and I'm going to calculate, they want to know the density. I've got the volume, which is 22.4 liters, and that is how many moles? That's 1 mole, right? So I might be tempted to use 22.4 grams, but I can't use that. I've got to use 1 mole. And what is the weight of 1 mole of hydrogen gas?
That would be 2 grams
right.
per
Remember,
1 mole.
It's H2, so it's 2 grams per mole. So grams per mole here, and this is liters per mole. So I end up with 1 over 11.2 grams per liter, and that's my density, which is very close to 1/10, which gives me choice A as my best answer. A little less than 1/10, so choice A. Okay, so the 22.4 grams was just a red herring. It was just to throw us off, and it just about did. Okay. All right, question 51. A cube of an unknown solid has a bulk modulus of 1.25 giganewtons per square meter. What is a giga?
It's a lot.
A giga is a lot, right. A giga is a 10 to the 9th, and you need to know that for the MCAT, all right? Giga means 10 to the 9th. So we have a 1.25 times
10 to the 9th.
10 to the 9th, and that is newtons per square meter. if it is brought to a depth of 40 meters below the surface of the ocean, so we're going to bring it down 40 meters. Here I've got my cube, and I'm going to bring it down 40
Notice what
meters.
John's doing here is it's hard to get your head around this question because there's so much text, so you want to give yourself a sort of reference point. First thing John does, and I don't even know if you're aware you're doing it, is he puts up a diagram. It's sort of automatic for him. It has to be automatic for you. I mean, you have to get yourself into that mode.
As soon as, and I'm not always aware that I'm doing it. In this case, I am. As soon as I look at a question and I don't know the answer right away, I don't know where I'm going right away, I just begin to draw it out. And that way, I don't waste time thinking. You know, I call it the sit and stare method. Oftentimes, people will read a physics question and they'll just sit and stare at it for a few minutes and think about it. Big mistake. As soon as you don't know the answer, as soon as you don't know the direction to go, begin drawing your diagram. Okay? All right, so what is the approximate percent change in its volume? The specific gravity of seawater is 1.25. So specific gravity of seawater equals 1.25. Okay. All right, so they're asking percent change in volume. So what this is a bulk modulus problem. And if I remember bulk modulus, for the bulk modulus problem, bulk modulus equals the change in pressure over the change in volume divided by the original volume. And this is in your book. It's a formula that you should know. Now, the change in pressure. What's going to be the change in pressure at 40 meters of water? If it were fresh water, it would be 4 atmospheres, right? And 4 atmospheres, because every 10 meters of fresh water is going to be 100 pascals or 1 atmosphere. But this is heavier than fresh water. That's what the specific gravity means, 1.25. So it's a quarter times heavier. So each 10 meters is going to be 125,000 pascals. I've got 4, so I've really got the change in pressure of 500 pascals. I want to use pascals, 500,000, thank you. I want to use pascals here because we're going to use, pascal is the SI unit. So the change in pressure is 500,000 pascals. And they give me, they're asking me what is the approximate change in volume. The percent change in volume, this is the fractional. This whole term right there is the fractional change in volume. Delta V over V0 is, you should just remember that. That's the fractional change in volume. If I take that and multiply by 100, I get the percent change in volume. So that's my answer choice. I'm going to bring that over here, and I'll bring the bulk modulus underneath here. So now I need the bulk modulus.
1.25.
And they give that as 1.25?
Times 10 to the 9th. That's the one we...
Okay. 1.25
times 10 to the 9th.
Times 10 to the 9th. That's my giganewtons, right, that they gave me in the question. And that's going to equal my fractional change in length. Okay. So I've got 5 times 10 to the 5th over 1.25 times 10 to the 9th. And that's 10 to the 5th over 10 to the 9th. So that gives me, this is 1/5, right? I'm sorry, this is 4. That gives me 4 times 10 to the negative 4th. And that is my fractional. And what do I want to do with fractional? I need to multiply this by 100 to get my change. So 4 times 10 to the negative 4th times 10 squared. I get 4 times 10 to the negative 2. And that's my percent change. 4 times 10 to the negative 2 is answer choice B. 0.04. So a very tough problem, kind of complicated. And one of the things you saw when I looked at the problem, I immediately went into drawing a diagram because I wasn't sure what was going on. As I drew the diagram, things became more evident to me, and I was able to find my formula. And once I found my formula, I recognized this was fractional change in length, which is what I needed, times 100, and that would be my percent change in length. And then I'd solve for that to get the answer.
Yeah, and there's really no way to solve this problem without doing the math. I mean, this is one of those where you just...
This is one of the few where you, exactly. It's one of the few problems where you go. And I always look for the easy way out for the problem. It doesn't mean it's always there. As you can see by R, it's almost always there. But sometimes it's not. Now, this whole thing took maybe 2 or 3 minutes. If I went beyond that, I'd stop calculating and I'd make a guess because I'd know I'm doing something wrong. If it requires too much time, that's a clue that you're doing something wrong. Okay? I always feel uncomfortable when I'm doing so much calculations on the MCAT.
Right.
I feel like maybe I'm doing something wrong. And that's a good feeling. You should feel like that. You recognize MCAT doesn't have a lot of calculations typically. Okay, question 52. The radionuclide K40 decays to AR40. The half-life for the decay is 1.25 times 10 to the 9th years. Mass spectrometric analysis of a moon rock sample reveals a ratio of 10.3 atoms of AR for each atom of potassium. If all the AR were produced by radioactive decay, what is the approximate age of the rock?
Wow.
This looks like a tough one, but half-life, you want to do it on your fingers. So let's just take a look at this. So we've got a ratio of 10 to 1. When I look at the mass spectrometry, I see that there's a ratio of 10 to 1 argon to potassium. If all of that argon were produced by radioactive decay of potassium, then how old is that rock? So what I'm going to do here, I usually do half-life on my fingers, but this one's kind of tough.
Yeah.
So I'm going to make a little chart, and I'm going to put potassium and argon, and then I'll count how many half-lives, okay? And this chart's going to be a ratio. So let's just start with, the potassium's becoming argon here. Mm-hmm. So let's start with 100, because that's a nice number, and 0 argon. Okay. The ratio here is 100 to 0, right? After one half-life, after my first half-life, I've got 50 and 50, ratio 1 to 1. The next half-life, what happens? I lose half of my potassium. So after 2 half-lives, I got 25, and over here I've got
75.
75. After 3 half-lives, I've got 12.5, and over here I've got 85.7. What's my ratio now? It's not 10 to 1 yet, so I'm going to keep going. 4 half-lives, I've got 6.25. I'll add 6.25 to this, and I get
94.
93. Oh, 94. Thank you. Okay, so now what's my ratio? More than 10 to 1, right? So the age of my rock is right in here, about 3.5 to 4 half-lives. Now I'm going to use my fingers. Now I'm going to figure this out. Each half-life is 1.25 times 10 to the 9th years, and I've got 3 to 4. So at 3 half-lives, I would have 3 times 1.25, or almost 4 times 10 to the 9th, right? 4 times 10 to the 9th at a little over 3 half-lives. That's choice D. Okay? So what I did, this is a very tricky half-life problem because they give me proportions here. And so what I did is I went ahead and made a table. I started out with after one half-life, I lose 50 and I gain 50. Another half-life definition is I lose half krypton each time. So I lose 25. That 25 goes over here. Potassium, thank you. I lose 25, that 25 goes over here. Another half, I lose 12 and a half, that goes over here. And I keep going till I get that 10 to 1 ratio. Here I didn't have 10 to 1 yet. Here I have more than 10 to 1. So I know the time is between 3 and 4. Now, so I know I have between 3 and 4 half-lives. So I'm going to figure out how many years in 3 half-lives? That would be 3 times 1.25, which is 3.75 times 10 to the 9th. And that is not quite D, but it's greater than C. So I know the answer choice has got to be D. Okay, tough problem.
It is.
All right, question 53. For question 53, I've written up the equations here on the board. And what I've actually done is taken the first equation and I turned it around, because that's what we're going to have to do. This question is going to ask us to take this reaction and put them together to make this reaction. In order to do that, I need carbon dioxide as a product, and I need carbon monoxide and oxygen as my reaction. So here, this has carbon monoxide as the reactant, and so I wanted this on the reactant side. So I had to switch that one in your book around. Okay. When I did that, I changed the sign of delta G0. All right, I still don't have it perfect because I'm making 3 O2s and then I'm only using up 2 O2s. And that is going to leave me with 1 O2 as a product. That's no good. I need to have 1 O2 as a reactant. So what I'm going to have to do here is multiply this reaction by 2. Okay? And when I do, let me go ahead and just go on through there. And this, I have 2 of these. That means I will have 4 of these. I'll have 2 of these. And I will have 4 of these. Okay. Now I see that I started with 4 waters and I ended with 4 waters. So they cancel. Let's see, I've got 2 COs. I start with 2 COs and that's it. So I have to bring the COs down to here. Then over here I make 2 methanes and I use up 2 methanes. So those cancel. I make 3 oxygens and I use up 4 oxygens. So these 3 cancel and I'm left with 1 oxygen that I'll bring down here. And then over here I've got 2 CO2s and that's what I wanted here. Okay? So there's my two reactants and my product here. Now when I multiply by 2 here, I need to multiply the delta G by 2. So what I have is negative 1602 kilojoules. I add these 2 together and I get approximately negative 5 something. Right? So I won't do the math, but it's negative 5 something. I look at 500 something.
Answer B.
Yep. Answer choice B. Negative 514 kilojoules. Okay. All right, question 54. The container of gas pictured below is insulated so that no heat enters or escapes. The pressure of the gas exactly supports a movable piston and 2 weights with mass M. What happens when 1 mass is removed? So let's just draw this out. Here's my container. Here's my piston. And here are my 2 masses. Okay, my gas is in here. Now the gas has a pressure, and that pressure is supporting this piston. And I've got the weight here, and the piston is frictionless. It's just sitting there, and it's exactly being supported, these masses, by the pressure of this gas. Now when I take one of these masses off, that's going to reduce the gravitational force down, but the pressure is still going to be there. And so the pressure is going to push up, and it's going to raise this piston to a certain level. As the piston rises, the volume of the gas expands. And as the volume expands, what do we know about pressure?
Pressure is going to diminish.
Exactly. Pressure is going to go down as volume goes up.
Well, this question is asking about temperature and volume.
Okay, so we know, so we solved one, that the volume is going to go up. So we know volume is going to go up, so that means it's either going to be A or B, and it could also ask about pressure as well.
Okay.
Right, and pressure is going to go down, so it looks like D could also be an answer. But we know pressure won't increase. As the volume goes up, the pressure won't increase. Okay, this is a very tricky question now because now we got to think about temperature as well. Because there are 3 variables here that are changing: pressure, volume, and temperature. So as the volume goes up, pressure goes down, and you might ask yourself, well, what's going to happen with temperature? Maybe temperature stays the same, right? Or maybe it goes up or maybe it goes down. So just the formula is not going to solve this question. You're going to have to know a little bit more about what's happening. What's happening is work is being done on this mass as it rises. And when you do work on a mass, you're putting energy into it, right? Its potential energy is going from MGH to MGH, whatever the H is rising, so there's more potential energy. Where's that energy coming from to do work on that mass?
Would have to come from the heat in the gas.
Exactly. The gas molecules are striking the top of this lid, and their energy is raising this mass. But when they do strike that lid, they bounce off more slowly. And if they're bouncing off more slowly, what does that mean about their temperature?
It's going to go down.
Exactly. So the gas molecules, by raising this mass, are giving their energy to that mass, and so they have less energy. So temperature is also going to go down. Pressure is also going to go down. So in this case, what I like to do is, and this is slightly cheating, but it actually is going to work for every question on the MCAT, is I like to think about temperature as the average kinetic energy per mole of gas. And I like to think about pressure as the average kinetic energy per volume of gas. And this way I see the volume goes up and the pressure goes down and the temperature also has to go down because I see that the kinetic energy, I focus on the energy here. It's always easier to think about energy. And the energy is going into the mass and out of the gas. If energy goes down, that means temperature and pressure must go down. Okay? So a tricky question. Our answer choice then must be A. The temperature of the gas decreases as the volume increases. Okay.
I also have one little mnemonic. Every time you use a can of compressed air to clean the keyboard on the computer, after too long that compressed air gets very cold, the can does. What's happening is you're expanding the volume of the container, or the gas is coming out of the container, so the volume of the gas is expanding, and that's why the temperature drops so precipitously.
Exactly. Okay.
Jordan! Oh, hi. How you doing? Hey, Jordan, they're here, buddy. Let's go. Let's go. Come on.
What?
Come on, man. All right.
What are we working on? What passage?
Passage 9.
Passage 9.
Yeah.
Oh, I had a power saw look like that once.
That's a cyclotron. Yeah. That's one heck of a machine. All right. Question 55. A proton is released from the ion source of a cyclotron, similar to figure 1, right here. The magnet generates a field strength of 1.6 Tesla. Holy mackerel. And the frequency of the oscillating voltage is 12 megahertz.
Whoa.
Which of the following describes the direction of the forces on the proton as it moves inside the D? Now, the thing about this question, you got the proton released here. It's going to move inside the D's here. And each D, then, is within a magnetic field. And what we know about a charged particle moving through a magnetic field follows the equation F equals QVB sine theta. V and B are vectors. F is a vector. So V is always perpendicular to F, and B is always perpendicular to F. So these two, keep that in mind, these two vectors are always perpendicular to F. So let's find the right answer. Choice D. Perpendicular to the direction of V and the direction of B.
All right.
All right. Notice all that extra language they
what is that,
pumped in there.
1.6 Teslas and the 12 megahertz?
That's
what the
just
heck is that
scary.
doing?
You can't be scared of that stuff, man. No, you can't be scared. Stay strong. All right.
Ah! Don't forget it.
Now, okay. 56. In a functioning cyclotron, a change to which of the following would not result in a change in the period of the particle's motion?
Whoa.
Oh, this one scares me. At first, I wasn't really scared, but at first, I thought I might be.
I was worried about you there.
I don't even know what scared feels like. Okay. But then I saw in the bottom of the passage, they got this formula. Q, the very last part, B equals 2 pi mf. And F is frequency.
Oh.
And I know that frequency is equal to what?
1 over the period.
All right, Big J.
Yeah!
So I'm going to substitute for F. I got a T there.
Right.
So let's take a look. In the functioning cyclotron, a change to which of the following would not result in a change? Okay, how about the mass of the particle?
Oh, definitely.
Changes the period.
Definitely.
The speed of the particle. It's not there.
Whoa.
Speed might be right. So I'm going to put a little mark by B. I think that might be right. How about C, the charge? There's Q. Q is the charge on the particle, changes the period. And then the strength of the magnetic field, that's B, changes the period, must be choice B.
Gotta be
Answer
B.
choice B, the speed of the particle.
Right, Johnny!
You can't let this stuff scare you.
Nah,
you know what I mean?
Can't.
All right, stay strong. All right. Which of the following particles could not be used in a cyclotron in a nuclear transformation?
Whoa.
Okay.
Nuclear transformation, man. Now I'm getting scared.
No. Don't be scared. I'm here. I'm here for you. Okay. We got the cyclotron here, and what we're going to do, they're asking which particle can we use in the cyclotron, okay?
Right.
And all you've got to realize is what? We need a charge on that particle, or there's no force, right? 0 Q means 0 force. It won't spin. There we go. So which one of the particles has no charge?
It's got to be a neutron.
That's right.
They're wimpy anyway.
Choice
No
C.
charge.
Choice C,
nothing.
no charge.
Ah.
Electron has negative charge, proton positive, alpha particle has charge,
2.
neutron no charge. C. Question 58. Bombardment of N14 with an alpha particle produces a proton, and which of the following? Okay, so we're going to take N14 and we're going to bombard it with an alpha particle. And you need to know that an alpha particle has a mass number of
4.
and a atomic number of
2.
Yeah, it's a helium nucleus, man. All right. And when we bombard that baby, we're going to get, let me just erase this part here. Okay. When we bombard that baby, we get a proton, right? It's got one proton, so it's a mass number of 1 and an atomic number of 1,
Gotcha.
plus something else, the mysterious X element.
Oh.
Okay. Now, nitrogen has how many protons?
Got 7.
Yeah, the mass number 7. So these numbers have to add up to these numbers. So 7 plus 2 equals 1 plus
Looks like 8.
6. 7 plus 2 equals 1 plus, oh yeah, you're
8.
right. Okay, all right, I haven't had algebra yet. Okay. All right, 14 plus 4.
18.
Okay.
17. Sorry.
Yeah,
18
man.
minus 1. 17.
That's 18, yeah, don't throw me off.
My bad.
Okay, yeah. Yeah, all right. So, what element has an atomic number of 8?
Oh, that looks like oxygen.
Oxygen. Oxygen 17, the answer is?
D.
D. Woo! All right.
All right.
All right, we're rolling.
We are,
We're
man.
getting done here. Okay.
Scaring me.
All right. A deuteron has the same charge as a proton, but twice the mass. Same charge, twice the mass. What changes should be made to a cyclotron in order to accelerate deuterons instead of protons?
Oh, my God.
Okay, all right. Notice the answers here. They're decreased by a factor of 2, increased by a factor of 2. What does that tell you?
It's got to be proportional.
Proportion. So I'm going to find a formula. They gave me one in the passage, this one right here, right?
I'm with you.
And we'll put that F back there because that's what it was. We'll take this off, and we'll take a look what they say. The deuteron, how's that different than a proton?
It's twice as massive.
And the same charge.
Yeah.
Right? Same charge, so Q's the same. M goes up by 2. We want to keep it the same, so what are we going to have to do, dude?
We're going to have to increase the strength of that magnetic field.
We're going to double it.
More
Up
Teslas.
2.
Ooh!
Yeah.
Yeah.
Choice B.
All right.
That's what I'm talking about.
I hear you.
We're done.
No, we got one more.
Oh, you're right.
60.
I got carried away there.
You did, but...
Which of the following expressions most closely approximates the rate of change in the speed of a particle as it moves from one D to the next D? There's a trick here.
There is. This is a tough problem.
Rate of change in speed. Rate of change in speed, that's like
Acceleration.
acceleration.
Whoa!
That's what I'm talking about. And acceleration then, oh, look at that. If I look at the answer choices, they're all different units. Acceleration is units of meters per second squared, right?
Gotcha.
What's a formula for EQ? Let's look at choice A. What is EQ?
That's force.
You should recognize that formula as force equals electric field times charge. So is that acceleration?
No, that'd be a force.
No, that's force. A's out.
Okay.
What do we need to get acceleration from force?
Well,
Oh, F equals ma, divide F by m, and we get acceleration.
I'm feeling you.
Do you have it? You got
B.
my answer?
Answer choice B.
Answer
That's it.
choice B.
Woo!
Ha! That's it now.
All right.
All right.
Hey, man, you want to go bombard somebody with alpha particles?
Let's do it.
Let's do it.
Let's do it. All right.
Out is this way.
When's Mom getting home? Passage 10, question number 61. Which of the following could be the average tension in each wire of a baby grand piano? Okay, to do this, we need to take a look at Table 2. On Table 2, we see under baby grand piano, we've got the total tension of 2.2 times 10 to the 5th. So if the total tension is 2.2 times 10 to the 5th, and we divide by the number of strings on a piano, and the first paragraph in the passage gives us 220 to 255, we should get the average tension. Now, I've got 220 to 255, so what number should I choose?
220.
Why 220, Jordan?
Because it's a multiple of 2.2.
Exactly. So 220 is 2.2 times 10 squared, and that's going to give me roughly the average tension. And since I chose the smallest number, 250 would make this tension smaller still. So I know that this will give me the maximum average tension. So these cancel, and I end up at about 1,000 is my maximum tension. So it's going to be 1,000 or smaller. That's answer choice A. Once again, rounding is the thing to do on MCAT. Question 62. If the fundamental frequency of a wire is 440 hertz, what is the frequency of its third harmonic?
All right, the fundamental frequency, you need to know the formula for this, and actually it's one of two formulas. In the case of a wire, I've got both ends closed down or tied down. It really didn't matter actually which formula you used here. Either one would work, but let's use the correct formula. L, the length of the wire, equals n lambda divided by 2. And here we want to put lambda in terms of frequency, and we know that we have the velocity equals frequency times the wavelength. So we have n, substituting for lambda equals velocity over frequency, we have n velocity 2 times the frequency. Okay, so it tells us that the fundamental frequency is 440, and it asks us for the third harmonic. So the fundamental frequency would be n equals 1, the third harmonic would be n equals 3. So if we triple n, what do we have to do to f?
We have to triple that.
We have to triple f. And so the fundamental frequency is 440. 440 times 3 is 1320. Answer choice B. Question 63. The wavelength of the fundamental mode of a piano wire is 2L. Which of the following represents the speed of a wave on this wire? Well, speed is given by this formula, velocity equals frequency times wavelength. And we see from the passage, they give the frequency as 1 over 2L times the square root of T over
M over L.
M over L. And then we'll multiply that by lambda, and they told us in the question that lambda is
2L.
2L, and that's my velocity. So these 2L's cancel, and I end up with the velocity equals, or the speed equals, the square root of T over M over L.
Answer choice A.
That's answer choice A. Notice another way to look at this problem on 63. Again, when I look at this, I see, oh look, they all have different units. So if I wanted to plug in units, I could also do that and find meters per second, which is going to be speed.
I think this is probably the more economical way to do it.
I think so too, because they gave me the formula. This is a quick way to do it. All right, page number 64. An upright piano can withstand considerably less total tension than a concert grand. What is one possible way for the two pianos to play the same notes? All right, if the tension is higher, if I can put more tension on the wire, what happens to the frequency?
It's going to go up.
Frequency goes up, pitch goes up. So the problem then is that the concert piano, or I'm sorry, the upright piano cannot play as high a notes as the grand piano because of the tension. But there's another way to make the notes go higher. And if we take a look at this formula, velocity equals 1 over 2L, T over ML, what would be the other way? If I can't add more tension, I could do something else. I could shorten the length of the wire, and that would increase the frequency. And let me go ahead and write that out. For velocity, I'll put, you know what I'm going to do? I'm going to go ahead and put the frequency here, the way they have it in the passage. Frequency equals 1 over 2L times the square root of T over ML. So here, as the length goes down, the frequency goes up. Okay, so my answer choice then would be B. The strings in an upright could be made shorter than the corresponding strings in the concert grand, thereby compensating for the upright's lower tension. Question 65. Which of the following graphs most accurately represents the relationship between the diameter of a piano wire D and the maximum tension? All right, so if we take a look here at our table 1, which gives me diameter versus maximum tension, and we can see, let me grab our graph here, our possible answer choices. When I get a graph like this, I'll put it here for now. The first thing I want to look at is the trend going up or down? And as soon as I can decide if the trend's going up or down, I can get rid of some answer choices. So here I see that as D, as the diameter, is going to go up, the tension is going up, right? Diameter versus tension. So I know B is out. So it's got to be A, C, or D. Now the question is it linear or one of these? And so I'll check for linear first. If it's linear, the rate at which this increases is equal to the rate at which this increases, or remains constant. The proportion that they each increase is constant. So here I see there's an increase of about 0.025, and here I see there's an increase of about 54. Okay, so 0.025 and 54. Over here, then
44 on this first one.
this one is 44.
Yeah.
Okay, you're right. So let me just write that down, actually. So between 13 and 14, I see that the diameter change is 0.025, and the corresponding tension change is
44.
44. Now let's look between 15 and 16. What's the change?
It's
And again, it's 0.025. And now what's my diameter change here?
44.
44. So that's a linear increase. And so for a linear increase, I'm going to choose A.
Absolutely. And what John did is absolutely, that's the only way I think to do this problem. So what you have to do, obviously on your MCAT, you'd write those numbers. I'd recommend you write them right there on the page so that you have them and you're looking at them right there. And you really have to do it for at least 2 sets. This way you see the trend.
Right.
Visually.
This worked out very well, 0.025 and 44. It may not work out exactly, and that's okay. So check maybe 3 of them and make sure they're coming out close. Okay. MCAT's not going to have them work out very slightly. It's going to be very clear on MCAT which way it's going, which way the trend is working.
Mm-hmm.
Okay, moving to problem 66. Some of the wires in the piano have identical masses, lengths, and tensions. Pianos are constructed so that depressing a single key on the keyboard causes these strings to vibrate simultaneously. What could be the purpose for this? So if they have identical lengths and tensions, they have the same pitch. They make the same frequency. So what could happen by putting 3 or 4 of them together? Well, if you have 3 or 4 of them together, it's going to be a louder sound at the same pitch. Louder means what in terms of wavelength? It means a greater amplitude, right? The amplitude doesn't affect the pitch. It's the amount of energy in that wave. So if we look at answer choice C, when sounded together, the wires could produce a sound of greater amplitude than any one of them separately. That's the correct answer. The other ones, I look at choice A, what is a chord? I don't know what a chord is, and I think most people taking the MCAT are not going to know what a chord is. We don't need to, so that can't be the right answer. Remember, science on the MCAT, 90% of the students taking that MCAT are going to know that science, so you're going to be one of those 90%. A must be wrong. B, when sounded together, the wires could produce frequency higher. Well, the frequency change is due to the tension and the length, as per the equation in the passage. And then D, it says beating. We wouldn't want to create beat frequencies when we sound the piano. We want to make it louder or quieter. So C is our only answer choice.
Hey, what's up? Passage 11. This passage really is about the half equivalence. In fact, we might even call it the half equivalence passage because there's a couple of questions here that are going to ask us to understand some things about the half equivalence point. Let's jump to question 67. It says carbonic acid is a weak acid. It gives us a Ka value. The conjugate base of carbonic acid is bicarbonate ion. And then it tells us some information about that ion. The conjugate base of bicarbonate ion is carbonate ion. So we've got HCO3 minus is the bicarb ion, and that will dissociate into CO3 2 minus and a proton. Good, so we've got an acid and a conjugate base pair, which they describe for us here. If an aqueous solution of 1 molar carbonate ion is titrated with hydrochloric acid, there will be an equal concentration of the bicarbonate ion and the carbonate ion when the pH equals which of the following. And this is essentially just definitional. The pH is equal to the pKa of an acid when the A minus or the conjugate base concentration equals the acid concentration. Essentially what we're doing is we're throwing up Henderson-Hasselbalch equation. I'm going to ask you to, not to memorize it, but to understand what's going on. So I just said it, and now let me take a step back and say again what I just said. We got an acid and its conjugate base. The acid will be represented as HA and the conjugate base as A minus. In the Henderson-Hasselbalch equation, what we have here, when we've got an equal concentration of each of these, as we do in this problem, and always at the half equivalence point, we'll have a ratio, this over this. If they're equal, the ratio will be 1. The log of 1 is 0. This part of the equation falls out. We'll give it a value of 0. And by definition, then, at the half equivalence point, pH is equal to the pKa of that acid. Let's find the answer choice that says that. Let me read the question again. If an aqueous solution of 1 molar carbonate ion is titrated with equal concentration of HCl, there will be an equal concentration of bicarb and carbonate ion when the pH equals which of the following? That would be the pKa of the bicarbonate ion. Cool.
So this question just gave a lot of extra information.
A whole lot of it.
And it was a pretty straightforward question.
It was pretty straightforward. It really asks, in a nice way, though, do you understand what's going on in Henderson-Hasbach? If you got our explanation here, I think you're pretty square there. Question 68 then. Again, more about the half equivalence point. This time we introduce a graph. And the graph is going to ask us, the question is going to ask us, what is the pKa of acetic acid? And then they're going to give us a graph that is going to represent the titration of acetic acid. Now the key here is, it's another point again about the half equivalence point. The half equivalence point on a titration curve is going to appear right here in the middle of the flat region of the curve. And at the half equivalence point, again, by definition, pH equals pKa. In other words, looking at this graph, the pH is equal to the pKa. At the middle point here on this flat region of the curve, we come over here to the vertical axis, which represents pH. We can see that the pH is a little bit greater than 4. The pKa must be equal to the pH because we're at the half equivalence point, and again, this will fall out. pH must equal the pKa. pH is a little bit more than 4. The pKa must be a little bit more than 4. Best answer then would be C for 68. All right, let's look at question 69. It says if 0.01 moles of H2S is dissolved in a liter of water, what is the H3O plus concentration? Let's take our graph up. Now, I took the liberty of erasing a little bit before. Let me erase up here. And, okay, so we don't know a whole lot about H2S, but it's a weak acid. It's going to dissociate into H plus and HS minus. And we can describe that dissociation, Ka is equal to the products of this reaction, which will be H plus and HS minus, H plus, which is what we're looking for. Actually, I might not call this H plus because each one of these protons is going to go find a water and protonate it. We'll call this H3O plus concentration and HS minus concentration. Put that over our reactant here, H2S. Now we know a couple things going in to this problem, so let's plug those values in. We know the Ka of this particular acid from the table, the Ka of acetic acid,
9.1 times 10 to the negative 8.
Thank you. Now I'm just going to simplify to 9 times 10 to the minus 8 is the Ka value, and that's going to be equal to H3O plus and HS minus. Now the thing about this is we don't know. I mean, we should know, and we can tell from this Ka value that this is a weak acid. We don't know exactly how much of this and how much of this is going to be formed, but we do know one thing. For every one of these that we get, we're also going to get one of these. In other words, we don't know what it is. We can set it equal to a variable. My favorite variable happens to be x. Let's set each one of these things equal to x. And because we have two of them, x times x, we're going to have to square that x. And we'll divide by the H2S concentration, which we can tell because it's given to us in the question as
0.01.
0.01.
Right. And it's 0.01 and minus x, because for every H3O plus formed, we lose x amount of H2S.
So we could say 1 times 10 to the minus 2 is the H2S concentration minus x. And the thing about this is a very weak acid. Ka describes the amount of products or reactants. This number is really small, 0.000000, etc., 9. Very small. X is going to be a really small number. So we could put in minus x here, or we could just say it's going to be so small, it's going to be inconsequential in relation to this. And that's what I'm going to recommend that you do. It'll make your life and your math a lot simpler. Now we can solve for x by multiplying both sides by 1 times 10 to the minus 2. And we get 9 times 10 to the minus 10
equals x squared.
Equals x squared. Now,
square root of both sides, 3 times 10 to the negative 5 is my answer choice, and that is answer choice B.
Beautiful.
Okay, so this was just really a little stoichiometry. Everyone's got to be able to do this. You have to be able to find out what is the pH of a weak acid. This was actually a very straightforward question with a little bit of work involved.
It is, and it is work, and if you're not totally square on it, what you should do is just set up a couple problems for yourself and work through them so that by the time you get to MCAT, it's
This should be an easy question for you. Yep.
Great. 70 then. What is the K sub B for OH minus? Now, I love this question just because it's kind of humorous in the way that it actually works itself out. The KB, again, the K of anything is going to be products over reactants, molar concentrations. But in this case, we're going to have OH minus and react it with water. And we're going to form, of course, OH minus.
Right. The OH minus is going to take a proton from water, leaving OH minus and creating water. So
if we set this up, we put our products, products over our reactants. The waters will probably fall out of this anyway because they're going to be so large in volume. Products over reactants, our products are going to be OH minus, molar concentration, and our reactant is going to be OH minus. That will be KB, of course.
Right, and we don't use water because water is a pure liquid, and we don't use that in our equilibrium concentrations.
Ratio here is this over this. They're the same thing. Ratio is 1. Best answer is D. 71. If the initial volume of the student's acetic acid solution is 5 milliliters, what is the concentration of the acetic acid solution before the titration?
Now let me try and answer this one, all right? Because I want to do some stoichiometry here.
Hold up, John. Just go ahead and sit back down. That's the tendency, right? You see this acid-base problem, you want to show them how much acid-base stuff you know. If you look at the note for figure 1, immediately below where it says figure 1, it says the titration curve for a 0.5 molar acetic acid solution titrated with 0.1 molar sodium hydroxide. In other words, what was the concentration before the titration? 0.5 molar. What's the answer choice, or what's the answer? C.
Okay, last set of standalones in physics. Let's get these done. Question 72. The pendulum shown below has a 1 kilogram bob. If the pendulum is raised to 10 centimeters and released, what is the tension in the string as the pendulum passes through its rest points? So here is our pendulum at the rest point, and if it's a 1 kilogram bob, there's a force downwards due to gravity of 10 newtons. Now, if it weren't swinging at all, what would be the tension in the string?
10 newtons.
Yeah, it would equal 10 newtons. But it's swinging. It's making a circle. So is the tension going to be greater or less when we swing it? And if you think about this, imagine you have a little pendulum on a string. Let's say it's on a thread. And I'm going to start swinging this. And it's a rock, a heavy rock. I start swinging it. And I start swinging it faster and faster. What's going to happen to my thread?
It's going to be taut.
And if I swing it really fast, the thread's going to break. You can imagine a thin thread with a rock if I'm swinging it fast. So what does that mean about the tension in the thread as I swing it? The faster I swing it, the more the tension is. So what that says is, if it's not moving, the tension is 10. If it's moving, the tension is greater than 10. Do I have to figure it out? I don't.
D.
Answer choice D. Okay. Now, if I wanted to figure that out, what I'd have to add is I'd have to look and see which way is it accelerating. And since it's moving in a circle, it's accelerating towards the center of the circle. That means it has centripetal force towards the center. And centripetal force, our formula is what?
mv squared over r.
mv squared over r. So that's our formula for force upwards. So what I know then, if it's coming this way, I know that the tension is equal to mg plus mv squared over r. mg is 10, and then this is going to be 1 times v squared. And you know what else I know? If it dropped 10 centimeters, and we won't go through all of this, but if it dropped 10 centimeters, I know that the velocity down here, the tangential velocity is v equals the square root of 2gh. So v squared would be 2gh. So this is 1 times 2gh over r, and r then is what?
1 meter is the radius.
1 meter. There we go. So we get the tension equals 10 plus 2gh. H is
10 centimeters.
0.1 times 10, so it's 2. So 10 plus 2 is 12. Yeah, you can see solving it is much longer than looking at it and kind of figuring it out and realizing tension's got to be greater than 10. Okay, question 73. Suppose solvent A has a lower freezing point than solvent B. If solvent A is slowly added to solvent B until the concentration of solvent B is negligible, which of the following graphs could represent the freezing point of the mixture as a function of the mole fractions of solvent A and solvent B? Okay, and then they give us the KFs. Now, this is kind of a tricky question. If we take a look, what do we know about a pure liquid versus a solution?
The solution is going to have a lower...
Exactly. If I start with a pure liquid and I add some impurity, I'm going to lower the freezing point. So if I start here with pure B and I add some A, I'm going to lower the freezing point. But on the other hand, notice this mole fraction. So one represents a pure solution of B. This represents a pure solution of A. So on the other hand, if I start with a pure solution of A and I add B, I'm going to lower the freezing point. So each one of these have to be going down from either side. And of course, they're going to meet in the middle. In reality, there's going to be a little splay and a little dip there. But this is about what it's going to look like. A is the best answer choice. Because when I add A to B, I lower the freezing point. When I add B to A, I lower the freezing point. Okay? When I make a solution, I add an impurity, I obstruct the crystallization, and I lower the freezing point.
Yeah, because freezing point, you have a colligative property called freezing point depression, and as you add solute to a solvent, you lower that solvent's freezing point, and that's essentially what you're talking about. Adding an impurity is the same as adding a solute to a solvent.
Exactly. Okay, question 74. The U-shaped tube below is open to the atmosphere and contains pure solvent on the left and non-volatile solute solution on the right. A semi-permeable membrane which is permeable to the solvent but not the solute separates the two halves. If rho is the density of the solution, which of the following represents the approximate osmotic pressure of the solution in pascals? This question is really the definition of osmotic pressure. If we take a look at this, the definition of osmotic pressure is the difference in pressure. It's the difference in hydrostatic pressure between this solution and this solution. So the hydrostatic pressure for this solution is going to be rho GH2. The hydrostatic pressure for this solution is going to be rho GH3. The difference between those two is going to be our answer choice, which is A, which is 10. 10 there is G, so 10 rho H1. The difference there, H1. And that is really the definition of osmotic pressure. It's the extra hydrostatic pressure involved when I add a non-volatile solute and fluid comes this way.
So the fluid, there's going to be two pressures working across the semi-permeable membrane. There'll be an osmotic pressure on this side because we have solute particle dissolved. You're saying fluid would be drawn across, so there'd be a pressure sort of working that way. And because of the height of this fluid relative to that fluid, there'll be a pushing of fluid that way. And at some point, they'll come to equilibrium. I guess that's where we are now. So you're saying the osmotic pressure, the tendency of the water to be drawn this way, is offset by the fluid pressure from this added height.
Yeah, and I want to be careful about talking about pressures in
Too
directions.
specifically, right.
Because a pressure doesn't have direction, it's a scalar.
Okay.
But certainly you can look at it like that. On the MCAT, right, you can look at it as osmotic pressure, and often people think of osmotic pressure as drawing in. So it's drawing in fluid. Hydrostatic pressure is pushing out. That's not technically correct because there's no direction to fluids, but oftentimes in the MCAT you can look at it this way. This actually shows exactly what osmotic pressure is. It's just the extra hydrostatic pressure due to these solute particles. Okay, so answer choice there is A. All right, question 75. Funnel X and Y are filled with an ideal fluid to the same height. The cross-sectional area of a funnel Y at the bottom is twice that of funnel X at the bottom. Which of the following is true concerning the funnels? Now, if I take a look at my funnels here, this question can be tricky. But if I want to know the fluid coming out of the bottom of a funnel, there's a formula for that. And it really comes from Bernoulli's equation, but we can solve it out to the square root of 2GH, where H is the height from the top of the fluid to where the fluid's coming out of the funnel. So in both these cases, my velocity is going to be the same coming out. So answer choice here is B. The velocities of the fluid coming out of the funnels are equal. Question 76. All the following must increase with temperature except Okay, the rate of any reaction, whether it's exothermic or endothermic. This throws people off sometimes because an exothermic reaction looks like this. A goes to B plus heat. And you think, all right, if I heat this up, I increase the heat, I'm going to push the reaction this way. That's true. But the fact is that's thermodynamics, and they're asking about rates. Although the reaction will go this way, the reaction will also go this way. The reaction will go both ways. I'll just increase the rate of reaction this more than I'll increase the forward reaction. So when I heat this up, I increase the rate of both directions. So A is a true statement. B, the Gibbs free energy of a spontaneous reaction. Will the Gibbs free energy of a spontaneous reaction increase? The key word here is must increase, and it means it doesn't have to increase. It could increase or decrease. C, the entropy of any substance always increases with temperature. The average speed of the molecules in a gas increases with temperature. So B is our answer. Question 77. A man stands halfway between a concave mirror and its focal point. His image will be, so we've got to find his image. So if we take a look at this man here, and here is the mirror, and here is the focal point. So we see this is DO, and this is F. And we see that 2F equals DO.
2DO equals F.
Thank you, sir. You're welcome. So F equals 2DO. So from the Finn's lens equation, we have 1 over F equals 1 over DO plus 1 over DI. And I'll plug in now for DO. I'll have 1 over 2 DO equals 1 over DO plus 1 over DI. Subtract 1 over DO from both sides. And I'll pull out the 1 over DO times 1/2 minus 1 is going to give me negative 1/2 equals 1 over DI. So I have, basically what I end up with is negative 2DO equals DI. Then I go to the magnification equation, which is height of image over height of object equals negative DI over DO. So DI equals negative 2DO. And over DO, the DO's cancel, and I end up with 2. So the magnification is 2. The answer choice is A. All right, and that's the end of physics.
Yeehaw!
Whoa. Jesus, who put this bucket here?
We're up to bio! Yay! I'm just so happy about this, John.
I'll be happy when we're done with bio.
We'll just do bio. Passage 1 talks about anemia. And certainly we'll go into the MCAT having probably, hopefully, not too much more information than the amount of stuff we'll cover here. 138 says the hematocrit of a patient suffering with nutritional anemia is most likely. Now, one thing you probably should know is that hematocrit is a measure of the number of red blood cells. And if you're suffering from anemia, that means you don't have enough. You have a lower than normal amount. So nutritional anemia means you have less than the normal amount of red blood cells. So C and D would have to be wrong immediately. And then B is wrong because it says lower than normal due to a high blood concentration of erythrocytes. And of course, an erythrocyte is a red blood cell. And the problem with anemia is that you don't have enough of those. That can't be the right answer. Must be A. Lower than normal due to a low blood concentration of erythrocytes. That's a definition I would know for the MCAT. 139. Sickle cell anemia is an autosomal recessive trait in which red blood cells may form a sickle shape and rupture. What type of anemia is sickle cell anemia? And it says in the last paragraph of the passage, hemolytic anemia is the premature lysis of red blood cells. This may be due to genetic defects. In other words, the right answer to 139 is a reading comprehension question. Sickle cell must be a type of hemolytic anemia because it's genetically based. 139 is D. 140. Based on information from the passage, which of the following best explains an anemic patient's low tolerance for cold in any type of anemia? Now, before you go ahead and go to the answer choices in this one, you know that anemia means you don't have enough red blood cells, And the answer here is going to talk about not only that you don't have enough, but why that would be important. And the thing about red blood cells, of course, is that they carry oxygen. That's going to be their most important function in the body. In fact, and that's what they are. I mean, they're big bags that carry oxygen. So let's find the answer choice that says that. A says not enough warm blood is available to circulate to the tissues. Well, now this one's kind of interesting because it talks about the fluid of blood, but not the red blood cell itself, which is where anemia is a problem. I mean, anemia is low red blood cell count. So A sounds like, all right, maybe that might be the right answer, but no, it's talking about fluid, not cells. B says not enough oxygen is delivered to the tissues to maintain metabolism for an adequate heat production. It's essentially exactly
there
what
we go. Right. The blood is, we don't have enough red blood cells. Red blood cells deliver oxygen. The tissues use oxygen, and when they do, they produce heat, right? Most of the glucose that's burned up with the oxygen, most of the energy in glucose is actually wasted as heat for the body. And so there's not enough oxygen, there's not enough burning of glucose, not enough heat production.
Great. So answer choice B agrees entirely with what we think it should. That's got to be the right answer to 140. 141. The clinical expression of anemia results from tissue hypoxia. Hypoxia meaning not enough oxygenation. Which of the following compensatory mechanisms would be expected in an anemic patient? Again, we're looking for somebody who's not perfusing well enough.
We have low
Hypoxic.
oxygen, we want to compensate, so we want to get higher oxygen. So which answer gives me higher oxygen?
Well, increased erythropoiesis in the spleen. Can you say that word?
Erythropoiesis.
Breaking down of red blood cells in the spleen. Obviously, that's a problem, and that's not going to increase your oxygenation or decrease hypoxia. Increased cardiac output. No, there's a compensatory mechanism. Your heart's going to work a little harder, push the little blood cell that you do have available around better, and maybe you'll be able to oxygenate better that way. C, increased osteoclast activity. You should know about an osteoclast. It's involved with bone and abnormally high serum iron. Not going to answer the question directly. Best answer for 141 is B. 142. Vitamin B12 is only available through animal products. A B12 deficiency can lead to anemia. The most likely reason for this is because, well, sounds to me like B12 is necessary as an important part of a red blood cell. So let's find the answer that says that. C says B12 is required to produce a coenzyme in the formation of an essential building block of DNA. Well, I skipped right to C there because I knew it was the right answer. That one, obviously, if you're going to make more red blood cells, you're going to need DNA to make those red blood cells, and that's going to be the best answer.
Another point here is that I think about this question as a vitamin. What do vitamins do? They often act as coenzymes, making C a good answer. A, B, and D have to be wrong. Cholesterol blocks the absorption of B12. I don't know why that would be. And you'd really need to have a reason for how that works. Energy from the metabolism of B12 is necessary for the synthesis of red blood cells.
It's not an energy source.
Right. So vitamins don't work by metabolizing vitamins. Vitamins work by acting as coenzymes. And then D, B12 catalyzes red blood cell synthesis in the spleen.
That just doesn't happen because you don't make red blood cells in the spleen. You break them down there.
Exactly.
So each one of those things have a little bit of must-know knowledge for the MCAT. C here, well, it seems like it's not a great answer, but it's the best answer of this group. And MCAT will do that occasionally. They'll try and play a game with language, especially in the biology section, where you'll say, I don't really understand, but you could see how it would mean what we're saying it means here in this case. And so clearly the best answer in my mind is C for 142.
Passage 2, question number 143. What is the shape of a carbon dioxide molecule? Okay, well, if you don't know this one, then I think you're in trouble. You really just have to know. This is linear. Carbon dioxide and water, you should know those two molecules just backwards and forwards. So answer choice 143, this is a gimme. That's A. 144. Aspirin is formed from salicylic acid by. Now, if we take a look here at reaction 1, where we've got aspirin.
Reaction 2 you want?
I want reaction 2. Okay.
That's it.
Okay. There we've got salicylic acid. And we take a look at our answer choices. Converting a carboxylic acid to an ester. Well, if I start with salicylic acid to form this, if I take the carboxylic acid and I convert it to an ester, what would I have? I'd have
here's the ester group. I'd have, this would be an ester, but then I'd have an OH, not aspirin. Okay, converting an alcohol to a carboxylic acid. If I turn that to a carboxylic acid, I have 2 carboxylic acids, not aspirin. Converting carboxylic acid to an alcohol, I'd have 2 alcohols then, would not be aspirin. Converting an alcohol to an ester, there we go, alcohol, ester, now I've got my aspirin. So answer choice D, 144 is D. 145, in a proton NMR spectrum, how would the peak for a methyl group of acetylsalicylic acid appear? So if I take a look, here's my acetylsalicylic acid, here's my methyl group, and so they're asking me how would my peak appear? Well, I take a look at my hydrogen here, I've got 3, and how many neighbors? Because the peak would be, the number of peaks would be neighbors plus 1. So how many? I go to the neighboring carbon, it has no hydrogens on it, so it should be a singlet. That's answer choice A. Question 146. The reaction converting phenoxide to salicylate ion is a, and so we take a look here at reaction 1.
Ooh, I know.
Yep.
We're adding CO2, so that would be a carboxylation reaction.
Very good, Jordan. And that's answer choice D. 146 is D.
Okay, that was an easy one.
Okay. Question 147. Which of the following molecules is not a resonance structure of phenoxide? Okay. So if we take a look here at these, actually what we can see, you know what, if we look at just our answer choices, we see that D has a different number of electrons than A, B, and C. So D must be a different structure than A, B, and C. And that's the easiest way to answer this question.
One of these things doesn't belong here.
1, 2, 3 lone pairs. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So D must be an incorrect structure.
We're up to passage 3 already. Starting with question 148. If the pH within a parietal cell remains close to 7 when the stomach is digesting a meal, what is the ratio of the hydrogen ion concentration outside the cell compared to inside the cell? I'm just going to use diagram 1 here, or figure 1 from the passage. We got the stomach lumen, of course, with a pH according to the passage. The pH is very low. According to the passage, it's going to be around 1-ish. And in the in this cell, according to the question, the pH within the cell is about 7. So we've got a pH ratio of 7 to 1. But the pH is a base 10 logarithmic scale, which means that the ratio is not actually 7 to 1. It's a really big number relative to 1, or a small number.
Exactly. Each pH point is a factor of 10.
Let's find the big number relative to the small number. It's got to be answer choice D, 1 million to 1. You should understand a large difference, or any difference on the pH scale, every one difference is a 10-fold difference.
Exactly.
Good. 149. Which of the following hormones stimulates parietal cells to secrete HCl? Now, as far as I'm concerned, this is simple science knowledge that you must know. You need to know that secretin is released in the small intestine. You need to know that insulin, released by the pancreas, it lowers blood sugar. You need to know that gastrin, which is the right answer here, stimulates parietal cells to secrete HCl. And you need to know that pepsin is a digestive enzyme that digests proteins in the stomach. So the best answer, 149, is C. Question 150. Based on the information in the passage, a peptic ulcer might be treated by all of the following except. And in the last paragraph, the first sentence of the last paragraph says, smoking, alcohol, and aspirin are contributory factors to peptic ulcers. In other words, aspirin can cause a peptic ulcer. So how would you treat a peptic ulcer? Hopefully you wouldn't treat it by the administration of aspirin. In fact, if you go to a doctor who gives you aspirin for your peptic ulcer, go away from that doctor. Best answer for 150 is going to be D. If it causes them, it's bad for the treatment. 151. Upon reaching the stomach, the salivary enzyme amylase most likely. Now, of course, we need to know a little something about amylase. Released in the saliva, its function is to start the digestion of carbohydrates. But being a protein itself, once it hits the stomach, it's going to be faced with this really low pH environment, and it will be digested itself, as will many proteins when they reach the stomach. Let's find the answer choice that says that. 151 says A. It's going to be affected by the low pH and may be digested. Would cease to function, certainly. 151 is A. 152. Immediately following a meal, the pH of the blood leaving the capillaries of the stomach would be expected to. Okay, so now, obviously, or maybe not obviously, the key to this question is immediately following a meal. Obviously, when we have a meal, our stomach becomes active. It's going to start the production of and the secretion of HCl into the stomach lumen so that we can digest that meal. In other words, we're getting these reactions to occur. Well, the reason that all these reactions are put into this diagram is that we need to see on this end, over here, HCO3 minus is going into the bloodstream. And if we drop HCO3 minus, which is effectively going to be a base, into the bloodstream, John, what's going to happen to the pH within the blood?
pH goes up with a base.
pH goes up. Let's find the answer that says that. B, increase to a decrease in hydrogen ion concentration. When we put the base in there, any H pluses might go up and attach to that base, diminishing the H plus concentration, increasing pH. Question 152 is B. Question 153. According to Figure 1, the net change in the charge inside a parietal cell for each 1 molecule of HCl produced is, well, it should make sense to you that if the function of this parietal cell is to produce HCl, it should make sense to you that there shouldn't be a net charge gain or loss. And in fact, that if you did have a net charge gain or loss, I mean, it just wouldn't make sense.
It takes a tremendous amount of energy to build up a charge difference from one side of a membrane to another. So you don't want to waste that energy by building that charge difference. So right away you should say the answer is A, 0. But if you look at the diagram, you can also just count. We got an H plus coming out, and a K plus coming out, and a Cl minus coming out. And then you can look at the other side there as well.
These are crossing over. We've got the sodium coming in and the chlorine coming in. So if you do the net reaction here, if you count up all the positives and the negatives, what you'll wind up with is a total net of 0 movement of positives and negatives in or out.
Exactly.
Great. 154. Every time I do this passage, I think peptic ulcers, man, they're so upsetting. Peptic ulcers most often occur in the small intestine, and it says essentially it's reading comp right out of the passage. The third paragraph says the most common site of peptic ulcers is the first few centers of the duodenum. You need to recognize the duodenum as the first part of the small intestine immediately attached to the stomach. So the best answer, 154, will be B, the small intestine.
Passage 4. Passage 4 is about diabetes, and it says in the passage that diabetes symptom is abnormally elevated blood glucose. So the blood has a lot of glucose, but for some reason the body's still starving. The glucose is not getting into the cells. So what happens here is we have the membrane, and then we have the proteins, the transport proteins that allow glucose to come into the cell via facilitated diffusion. And in order for that to happen, we have to have insulin attached to the cell, and the insulin actually causes these facilitated transport proteins to be created and be put into the membrane. So either there's not enough insulin, or for some reason this process is not happening in diabetes. The glucose is not being able to get into the cell. Question 155. Injection of insulin is accompanied by the risk of infection. What is the most likely explanation for insulin not being given orally? Well, here we want to recognize that insulin is a peptide hormone. In other words, it's a protein base, and proteins are digested in the stomach, or denatured in the stomach at least. So answer choice A, insulin is digested by proteases in the stomach and the small intestine. Answer choice A. If we give insulin orally, it'll be destroyed in the stomach, so we have to inject it. Question 156. You want to handle this one?
Sure. This is kind of an interesting question because it's kind of tough to get our head around it sometimes. 156 says, which of the following observations would best support the conclusion that type 2 diabetes is caused by overeating? And we can look at the answer choices here, and type 2 diabetes, as John related to earlier, essentially talks about the level of insulin around. A says non-diabetic obese individuals have approximately twice the insulin levels of thin individuals. So in that particular answer choice, if that were true, that would support the idea or be proof of the idea that obesity affects your insulin levels and might be support for the conclusion that type 2 diabetes is caused by overeating. And if you look at the other answer choices, and if you picked one of the other ones, I just want to look at a couple of them. B says obese individuals overeat. Well, this may be a true statement, but so what? It really doesn't answer the question. You look at answer choice D. D says not all obese individuals are diabetics. Well, now that would tend to weaken the causal link between obesity and type 2 diabetes. So certainly B and D have to be wrong. And then C says patients suffering with obesity typically exhibit a reduced number of pancreatic beta cells. This one's no good either, because A really is going to be a proof that obesity is going to affect insulin levels, where...
Well, I think C is referring to type 1 diabetes, right? And type 1 diabetes, it says simply a hereditary tendency
Yes.
for beta cells to degenerate. So that's not the type 2 diabetes. So that's why C is wrong.
Perfect.
So we end up with A. Okay? Question 157. All of the following would be symptoms common to both type 1 and type 2 diabetes mellitus except. And here the answer is D, and it says in the passage type 2 diabetes may be caused by overeating. So obesity may be common in type 2 diabetes, but type 1 diabetes is, you tend to have thinner individuals. They have the tendency, let's see, it said in the passage you have, they tend to be infected more easily and less healthy. Actually, type 1 diabetes individuals tend to be thin. So answer choice D is the correct answer. Question 158. All of the following hormones are likely to be elevated in a patient suffering from type 1 diabetes except. Now, remember what happens with diabetes is we have a lot of glucose in the blood. So we're looking for the hormones that are going to be elevated are the hormones that are putting glucose in the blood. The cells are starving. The cells are sending messages to the glands saying, we need more glucose. Even though there's a lot of glucose here, it's not getting in. So the cells say we need more, and the glands put out hormones to create more glucose. Which hormones are going to create more glucose? Cortisol, epinephrine, and glucagon. Parathyroid hormone does neither create nor or reduce the amount of glucose in the blood. So C is the correct answer because the question is an except question. Question 159. Which of the following cell types is not prevented from absorbing glucose due to low blood insulin levels exhibited in diabetes type 1? So the cell types here, what you need to know is that neurons in the brain are not insulin sensitive. Most of the cells in the body are sensitive to insulin, where when they're exposed to insulin, they create more transport carrier proteins. Neurons do not. Neurons will automatically allow glucose to go in, so they'll take glucose without insulin. So they're not sensitive to the insulin. Answer choice B.
Yeah, and you should definitely be aware of that. I mean, if you don't know that already, neurons have their own mechanism for transporting glucose. I mean, it's imperative that our brains have sugar.
Right.
So that's what's going on there.
Okay, problem 160. If a patient suffering from type 1 diabetes self-administers an excess amount of insulin, insulin shock may result. An appropriate treatment for insulin shock would be, all right, so if this patient injects insulin and gets this type 1 diabetes, he's not getting enough insulin. So the glucose is there, but it can't get through because there's not enough insulin. He injects insulin. The insulin causes many of these proteins to be made, causing the glucose suddenly, his blood level glucose is going to go way down. Now, what's going to happen when the blood level glucose goes way down? His brain's not going to get that glucose, the amount of glucose he needs. So we need the glucose to come back up. Normally, you might just give him a candy bar or a fruit juice or something like that, but that choice is not given here. So what choice is going to bring that glucose up? Which one of the possible choices? Answer choice A, an injection of glucagon will bring the glucose levels back up. The other choices do not work.
Right. If you chose answer choice C, I hope I don't have you as my doctor someday. To have the patient eat half a bar of butter, yuck.
Butter's just not going to bring you any glucose. Butter is fat.
Right. The first set of freestanding questions begins with question number 161. Insects do not use blood to deliver oxygen to their tissues. Insect blood probably does not contain, now this question is clearly, at least as far as I'm concerned, about the carrying of oxygen. And the thing that carries oxygen in our blood, yes, red blood cells do, but the thing that they have within them that carries oxygen is hemoglobin. So while answer choice C and D seem like they might be good, answer choice D is better because its only function in our bodies is to carry oxygen. So the best answer here is going to be D for 161.
Yeah, if you look at it, it's very difficult to choose between C and D. And if you look at it, if you had erythrocytes but not hemoglobin, you're not carrying any oxygen. If you have hemoglobin but not erythrocytes, you still carry oxygen. So hemoglobin is the better answer.
Excellent. Question 162. Which of the following cells produces antibodies? So this is, again, core science knowledge. You just have to know it. The function of a plasma cell is to produce, antibodies. Macrophages phagocytize things, T cells involved in immunity, and monocytes, no, plasma cells produce antibodies. Question 163. Which of the following is the weakest acid in aqueous solution? Immediately we look at this one, we look at our answer choices, we can eliminate D, that's an acid, that can't be the weakest, and A is water, it's neutral, that won't be our weakest. So the question is, which one? Is it the ethanol or is it the phenol? And what you need to know is that phenols in the realm of alcohols, they're relatively stronger acids, making our weakest acid here the ethanol, answer choice B.
Right. You should just know alcohols are weaker acids than water. Phenol is an exception. It's a little stronger acid than water, and that's because the benzene group is electron withdrawing.
Great. And finally, 164, which of the following is most likely the smallest? And immediately I look at this at the answer choices again. Bacterium and mitochondrion are going to be similar in size, and a virus can infect a bacterium, so it's got to be smaller than a bacteria, which is about the same size as mitochondrion, and a protein can make up a part of a virus, so the smallest of this group must be a protein. Poor little protein. Answer choice D for 164.
We're on passage 5. Passage 5, question 165. The normal first cleavage of a leopard frog egg is, now it's said in the passage, last sentence in the first paragraph, if the resulting two cells are separated, the resulting cells from cleavage are separated, a normal tadpole will develop from each cell. So what that means is those two cells are identical and their fate has not been determined. So the first cleavage is indeterminate, and that is answer choice B. Question 166. The eye lens in frogs is formed from which germ layer? You need to know eye lens is formed from?
Ectoderm.
Ectoderm. This is just knowledge. You have
Straight
to know
up.
that. Answer choice C for 166. 167. The process by which the optic vesicle causes the epidermis to become the eye lens is called, well, it said in the passage that the optic vessel bumps up against the epidermis and makes it the eye lens. That's called induction when that happens. So answer choice is B. Again, you need to know this term, induction.
Right. Induction doesn't necessarily cause by bumping up. It's a chemical signal from one cell to the other that's going to cause this eventual
It's going to induce differentiation. Exactly. 168. Which of the following did not occur during gastrulation of the salamander embryos in experiment 1? And during gastrulation, we get mesoderm formation. We get the formation of the three germ layers, meso, ecto, and endoderm. We get involution. Involution is the folding in of the cell, or I should say of the blastocyst. And then mitosis also occurs, making more cells. But neural tube formation occurs during neurulation.
The next step.
169. All of the following statements are true concerning cleavage in mammals except, correct answer here is C. The individual cells formed by cleavage are similar in genetic and cytoplasmic content. If you recall, during cleavage, the end result of cleavage is a morula, and a morula has different size cells. So you have the vegetal region and the animal pole, and these cells are different sizes, so you have a different amount of cytoplasm in these cells. So answer choice C is correct for 169. 170. All members of the phylum Chordata have all the following characteristics at some point in their development except, and here again you just have to memorize this, a notochord pharyngeal slits and a dorsal hollow nerve cord, and then a tail is what's left out here. Backbone is not part of the phylum Chordata, not necessarily. You've got the phylum Chordata is split into two subphylums, which is vertebrata and invertebrata. Obviously, the invertebrata do not have backbones, and the vertebrates do. So answer choice here is B.
All right, we're going to do passage 6. My question is, John, why do I always get the organic chemistry passages?
Because that's the way I work it out.
Because you're smart. 171. The degree of unsaturation D is given by the following equation. D equals blah, 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 where N is the number of carbons and X is the number of hydrogens. How many degrees of unsaturation does cholesterol have? So there's actually a couple ways to do this problem. You could actually do the math involving the formula, or to find the degree of unsaturation, you count the rings and the double bonds, and whatever you come up with, you got it. So cholesterol has 1, 2, 3, 4 rings and 1 double bond. Sum is 5. Best answer, C.
Right. MCAT, as usual, gave you the hard way to do it, and there's an easier way to do it. So that's what happened here.
Great. 172. An intermediate in the bromination reaction is a tertiary carbocation. How does the bromide ion attack this carbocation? And what I've done is I've taken the liberty of drawing figure 2 up here on the board. And the most important part of figure 2 here are these 2 bromines right here. And what's interesting to me anyway is the way that they're drawn up there. It may not be so absolutely clear, but these 2 are on opposite sides of this ring structure. In other words, this one's on the back and this one must be then on the front. So when the carbocation is formed, the bromine, let's say, was here. This bromine, when it attacks, has to attack from the other end of the ring, making answer choice B correct.
This is also a reaction you should know. When you add Br2 to a double bond, you get anti-addition.
Great. And you know what, I just noticed in the passage, it also says pretty specifically, second sentence of the second paragraph, the bromine adds to the alkene of cholesterol, which would have been right there at that, right in this area. It adds to the alkene of the cholesterol in a trans configuration, which would mean opposite sides. So clearly, 172 is B. 173, cholesterol is a steroid. The structure of another steroid, testosterone, is shown in this figure. In which molecule does the carbon marked by the arrow have a higher oxidation state? So essentially we've got a hydroxyl group here, and we've got a carbonyl group on this carbon. The carbonyl carbon is going to have a higher oxidation state than the hydroxyl carbon. Testosterone, answer choice A, is correct.
Right, and you should recognize that reaction, going from an alcohol to a ketone, is oxidation. So
great. 173 is A. 174. After the initial isolation of cholesterol from the gallstone, the melting point of the sample was taken. Which melting point is most likely correct for this sample? Now it tells us in the passage, the last sentence, that the melting point for cholesterol is 149 to 150 degrees Celsius. That's for pure cholesterol. So when we do freezing point depression, remember that's a colligative property which happens when we add a solute or add some impurity to this compound. We're going to depress the freezing point. So the freezing point is going to have to be below 149 to 150. In other words, there's no way answer choices C or D could be correct. So John, I've narrowed it down now to answer choices A and B. There might be a couple ways here that I might answer this question. I'm going to jump on A because typically when you put an impurity in here, you're not going to get a boiling point. So I don't really like answer choice B because that's a point, whereas answer choice A gives me a range over where the freezing point might be.
Exactly. An impurity will cause a freezing point range, not a freezing point.
Great. Good. So the best answer for 174 is A.
Jorga! Jorga! We have test. What that?
Oh, I don't know, but it's pretty.
Oh, okay. Okay. What's your passage?
I Jorga. This Jonga.
I say my name. Where's my club? Okay. Which passage?
Passage 7.
Oh, I make picture. I saved Jorga life.
Oh!
Yeah, you remember? Oh, okay. Okay. Passage 7. 175. The symbiotic relationship between bacteria, and the intercellular bacteria is best described as...
I have friend named R. Bacteria. What kind of relationship?
Your friend, protist.
Protest.
Okay. Relationship. Mutualism.
You do.
3. Again, I talk better without teeth. Thanks for the buffalo kicked my teeth out. 3 type symbiosis.
Okay.
Parasite, make diagram. I good artist. Here, hold that.
Okay.
3 here. Mutualism, symbiosis relationship, mutualism, both happy. Yeah, both help each other.
Okay.
Commensalism, one happy, other no care, no care, no care. Okay. Parasitism, one happy, other no like, no like. Okay. This one, bacteria, friends, help other creature.
C.
C, answer C. Mutualism. Mutualism.
Fix.
You, yeah. 176. The bacterium in the trophosome of R. bacteria is an example of, answer choice here, chemoautotroph. Chemoautotroph.
Chemoautotroph.
Yes.
Make on, auto, chemo, no use, son.
No, sir, I explained better. Okay. Photon, energy from sun. Chemical, energy from chemical. Okay. Bacterium, energy from chemical. Auto and hetero. Hetero, eat others, get carbon from others. Auto, get carbon, fix carbon himself. Okay.
C.
Bacterium C. Chemoautotroph. You break 4 or you fix. Okay. 177. In order to produce ATP, R. bacteria probably acquires energy directly from
D.
breakdown. He's chemo. Breakdown of carbon compounds synthesized by bacteria within trophosome. Reading comprehension.
Very similar question.
Yes, chemo.
Okay. 178.
Which of the following is most likely true concerning bacterial symbiont within the trophosome of R. bacteria? Facultative anaerobe. You must know for MCAT.
Okay.
What MCAT?
I don't know.
I don't know. Okay, you must know for MCAT. MCAT, facultative, mean use oxygen if there. If not there, no use oxygen. Okay, oxygen, no oxygen. Yeah, facultative. Okay, no facultative aerobe because oxygen get much more energy.
Right.
Right, so oxygen there, use oxygen. No oxygen, that's okay too.
Okay. Best answer. B. B.
Don't break floor. Okay, 179. It has been proposed that the bacterial symbiont also provide our bacteria with nitrogen. Which of the following molecules is most likely the proposed source? Nitrogen, okay.
Nitrogen in answer D. N.
Oh, N2. No good, no good. Look. N2, 3 bonds. Very difficult to break. Only bacteria break nitrogen. Break this. Only bacteria, no animals. Wrong answer.
D. No good.
D, no good. Bicarbonate.
No nitrogen.
No nitrogen.
Oh!
Stupid answer. Stupid. Succinate. I think passage say succinate in Krebs cycle.
Yeah.
Yes. No nitrogen in succinate. in
Bottom
Krebs cycle.
third paragraph. Say exactly that.
Thank you, Jorga. Okay. Last answer. I hope it's right. Glutamate. A. Glutamate amino acid has nitrogen. Amino acid has nitrogen. I draw backwards. Okay.
Oh.
Nitrogen.
Generalized structure of amino acid.
Nitrogen.
Nitrogen.
Right answer.
Best answer A.
A. 179.
A.
180. An alternative hypothesis to the symbiotic relationship described in the passage is that the bacteria serve directly as food. Which of the following, if true, would most weaken this alternative hypothesis? If bacteria food, mini bacteria die. Growth phase, funny, up and down, maybe down a lot, because many die.
Born, eaten, die. Born, eaten, die.
Very good. Okay, no. So, electron micrographs indicate that the bacteria are in a stationary growth phase. Stationary, no eaten, no die.
Hey, best answer!
Hey! Okay, I put teeth back.
You know, this question make me hungry. Let go.
Kill something.
Yes.
Kill something. I need my club. Yeah, you can't use door. Give me yours. Okay. Go! Kill! Kill!
Biopassage 8 begins with question 181, which asks, what is the R sub F value for tyrosine? So what we need to do is we need to throw figure 1 up here, and we need to combine with figure 1 the formula listed in the top of the second column of the passage, which gives us the RF, the value to calculate RF. And that would be the distance from the origin, this would be the origin line, to the spot. And the spot that we're looking at here for tyrosine, this would be tyrosine, this is the spot, this is how far the tyrosine migrated. So that distance would be, from the origin to the spot, would be 6 centimeters. And looking again at the formula, the denominator here would be the distance from the origin to where the solvent went to. That would be 12 centimeters. 6 over 12 is 0.5. Best answer for 181 must be B. Simple math problem. Actually, interpret graph math problem. 182. How many residues were present in this sample of hydrolyzed gelatin? Well, what's going on here is that we're looking at the unknown, and we want to know how many different things, how many different parts were within the unknown. And all we need to do here is count the number of spots that were made. We've got 1, 2, 3, 4, 5 spots made. Best answer for 182 must be D. 183. Which of the following is the most likely identity of the spot marked by the arrow in figure 3? In other words, this spot, what is the most likely identity? Now, this one actually takes a little thought because you got to sort of do process elimination. A says glycine. Glycine would be indicated by a spot here. That's clearly not that spot. It can't be A. B says valine. Valine would be indicated by a spot here. That's not the arrow marked spot. It can't be B. Alpha hydroxyproline. That's not one of the standards, so that might be the answer. Let's just check D. Tyrosine, we already saw, is marked by this spot. That's clearly not the spot marked by the arrow. The only answer, the best answer must be C. We don't have a measurement value.
Okay, so let's just clarify this. So the UNK is the unknown, and we blot the UNK on that piece of paper. We blot our unknown on that piece of paper, and then the other ones are all controls. We know we have glycine. We blot it on the piece of paper. Can you show where we blot that?
Where we have glycine?
Yeah, with the glycine.
We would spot it right here at this crosshairs.
Yeah, so the paper, we start out spotting with glycine, valine, glutamine, the unknown, leucine, cysteine, and tyrosine here. Then we put it into the solvent, and then it elutes this way, and then each one of these dissolves, and as they dissolve, they move up the page. And then based on their polarity, they'll stick to the page as the solvent, they become less and less solvent in the solvent. So the solvent climbs up to here, and then each one of these climbs up there. Then we see our unknown, it's spread out, and we can compare our unknown and find what was in our unknown.
Great. Thanks, John. So we're up to 184. Which of the following amino acids is not found in the hydrolyzed gelatin sample? So this question now is sort of the opposite of the one immediately before it. Which one is not found in the hydrolyzed gelatin sample? Glycine. Here's glycine again. Glycine migrated this far. We see in our unknown we had a compound that migrated a similar amount. probably is, or must be, according to the information presented, must be glycine. Cysteine is here, migrated to this spot. There's something in the unknown that migrated to the same spot. That in the unknown must contain cysteine. Leucine, we've got a spot here for leucine. There's a corresponding spot in the unknown. The unknown must contain all three of those. Let's check valine. Valine is here. It migrated this far. There's no corresponding spot in the unknown. There must not be any valine in the unknown. So now we're starting to know what's in there and what's not. 184, clearly the answer is D. Question 185. Which of the following is not true of the bond marked by the arrow in Figure 1? And what I've done here is I've drawn the left-hand side of Figure 1, and hopefully you can clearly see the bond marked by the arrow. What's going on is this is a special kind of bond called an amide bond, and in this case it's between two amino acid residues. This is a peptide bond. And the peptide bond has a special characteristic. The lone pair of electrons on the nitrogen come over here. Because of the similarity in electronegativity of the nitrogen and the oxygen, this lone pair will jump across. This pair of electrons will jump onto the oxygen, giving this a negative charge and this a positive charge. So what we form here is a partial, or this bond is known to have some double bond character. And the importance of that, as far as we're concerned, is that single bonds allow free rotation, double bonds do not. So when we look at our answer choices, B says the bonded atoms are free to rotate about the axis of the bond. By definition, in a peptide bond, they do not. Good. Question 186. The best explanation for the fact that leucine has a higher R sub F value than glutamic acid is, essentially this is reading comprehension out of the first paragraph in the second column of the passage. It says the distance traveled by an amino acid along the paper chromatogram is dependent upon the polarity of the amino acid's side chains. So the distance that it travels on this chromatogram is dependent on the polarity of its side chains. The ratio of this distance to the distance traveled is by the solvent is known as the RF factor. So the best explanation for leucine having a higher RF value than glutamic acid, remember RF value means it's the distance from the origin to the spot over the distance from the origin to the solvent. So if you have a higher RF value, that means the spot traveled further. We're looking at leucine and glutamic acid. We look over here and we've got leucine and glutamic acid here. Clearly we should know, especially because we're calling it glutamic acid, we've got a polar side chain on glutamic acid, whereas we look at leucine, there's no polarity here. This one is more polar, so the best answer to 186 has to be B. Glutamic acid has a polar side chain, leucine does not.
Question 187, the second set of standalones. So question 187, reduction division during spermatogenesis produces a, now if we look over here, I've drawn it out. Spermatogenesis is meiosis. We start with the spermatogonium, it's going to be a sperm. We go to, after we get synthesis, right, no division, we go from a spermatogonium, we get synthesis of the DNA, or replication of DNA, we get the primary spermatocyte. Then our first division is reduction division, and this is splitting homologs. Here, this is a diploid. These two secondaries are haploids, and then after the next division, we get the gametes. So reduction division is the first one because we reduce the ploidy number from 2 to 1, and what do we end up with? We get a secondary spermatocyte.
That's definitional. You get a primary spermatocyte. That happens before meiosis 1. But meiosis 1, the definition is the reduction division. You go from diploid to haploid, and you get a secondary spermatocyte.
Okay, question number 188. The partial negative charge on oxygen of a water molecule is, if we take a look at a water molecule, here's the oxygen, here's the hydrogen, and lone pairs of electrons. Now, if there's a partial negative over here, and these have partial positives, each of the hydrogens have partial positives, we know that the whole molecule is neutral. So this partial negative must be twice as big as either one of these partial positives. The answer choice then is C, twice as great as the partial positive charge on either hydrogen. Question 189. Eukaryotes use all of the following molecules for long-term energy storage except, it's kind of a tricky question. Glycogen, yeah, that's a way to store energy. Starch, also a form of storing energy. And triglycerides, also a form of storing energy. ATP is a short-term energy storage. It's really the energy that's readily available to the cell, so it's short-lived. So answer choice is B, is the best answer choice. Question 190, how are cancer cells similar to single-celled organisms? And answer here is A, they can live independently of other cells in the body. And this is an important difference between single-cell organisms and multicellular organisms. Multicellular organisms, the cells have specialized and cannot live independently of other cells in the body. They have to communicate with other cells, and they depend on those other cells to do things for them. In a single-celled organism, these single-celled organisms can live independently. In cancer, it's the same thing. You get a cancer cell, and it lives independently of other cells in the body. Answer choice here is for 190 is A. 191. A living cell contains many specific molecules that are not protein-based. The best explanation for how a cell acquires these molecules is, answer choice C is the best answer, genes code for enzymes which direct the synthesis of non-protein-based molecules. What this is getting at is if genes only code for proteins, how can we get fats and how can we get carbohydrates? Well, what happens is and then hormones and other molecules. And what happens is these proteins act as enzymes that govern the reactions that create and harness the carbohydrates and the fats. So best answer choice here is C. Passage 9, question 192. According to the passage, what is the likelihood that a man with normal PSA levels has prostate cancer? This question seems to cause a lot of problems for people because they read from the passage, normal PSA levels may be found in 25% of men with cancer. So you might go right to choice B, which is incorrect. Let's look at it this way. Let's say we have 1,000 men represented by this box. And of these 1,000, 10% have cancer, right? Say 100 of them have cancer. That would be the red box right here. Of these 100 then, 25 would have normal PSA levels. What about these 900? What about the 900 over here that don't have cancer? What are their PSA levels? Probably normal, right? So the amount of people that have normal PSA levels are really 925 out of a total 1,000. So it's actually going to be a very small percent that actually have cancer there. So probably less than 25%. The likelihood that a man with normal PSA levels has prostate cancer is very, very small. All right, question 193. Side effects of hormonal therapy may include all the following except. Now, it said that hormonal therapy, the last sentence in the passage, since testosterone stimulates tumor growth, hormonal therapy aims at inhibiting the action of testosterone. So if we inhibit the action of testosterone, testosterone also stimulates spermatogenesis. So we inhibit sperm production. So A would not be true. A would be the accept answer. A is correct for 193. 194. Studies show that mortality from prostate cancer tends to be highest in countries that consume the most fat. However, the incidence of a silent microscopic cancer is essentially the same worldwide. Which of the following conclusions is most justified by this information? So apparently what's happening worldwide, the same amount of people are getting this microscopic cancer. But if you eat a lot of fat, it is growing. So best answer here is D. Dietary components may stimulate the growth of cancer cells, but they do not affect the process by which a cell becomes cancerous. Great. Question 195. Which of the following would be most helpful in measuring PSA levels? And here, from the passage, we see a radio-labeled antibody. That's how they do it in the passage. It's a reading comp question. Answer choice B.
Yeah, that's always going to be the answer. If they're trying to identify a certain compound, the best way on MCAT is going to be radio-labeled something, in this case, a radio-labeled antibody.
Okay, question 196. According to Figure 1, which of the following symptoms would give a prostate cancer patient the best prognosis? Okay, so this is a tough one. We're going to have to look at both graphs here because they give us both graphs. Notice here on the axis, this is percentage with prostate-confined disease at surgery.
So if you have prostate-confined disease, that's a good thing. You want it confined to your prostate. If it's not confined, it's going to be all over the place. So we want this to be a high percentage. That means healthy. Low percentage means that's bad news. Okay, let's take a look at our choices. A T1 tumor, so a T1 is going to be, this is my T2. For T1, I'm going to be over here. For a T1 tumor, I've got PSA levels of 4.5, so I'm right here. These are my PSA levels, so I'm right on this line.
And a Gleason score of 7.
A Gleason score of 7. And the Gleason score of 7, you can see here, is the diamond. So right there, I'm at 49. Remember, I want to be high for a good prognosis. And the question is asking me the patient with the best prognosis. So that's 49. Let's look at the other T1 tumor. PSA level of 15, which would be between 10 and 20, and then a Gleason score of 5. And the Gleason score of 5 is a circle. I'm higher. So B is better than A so far. I'm at about 60 with choice B. Now let's go to choice C. And keep in mind, choice B is about 60. So choice C is a T2 tumor. And it says a PSA level of 8.2, which is going to be between 4 and 10. So in this line right here. And a Gleason score of 3. The Gleason score of 3 is the black dot there. So we are up to almost 70 here. So C is my best answer so far. And D, T2 tumor, PSA level of 23, which is above 20. You can see I'm going to be very low. Bad news here. So answer choice C is my best answer, the best prognosis. So 196 is C.
Yeah, and sometimes this MCAT would classify this as a graphical or a data interpretation problem. And you really, I mean, the only way to solve this problem is to do exactly what Jon did. Just look at every answer choice individually and go through and graph which one, in this case, is the highest on either of the two graphs.
Exactly. And the key here was to notice the axes and understand what the axes said. That's the first thing I looked at to make sure I understood, was it good to be high or good to be low? Question 197. Current studies include research into a vaccine which would incite the immune system to attack cancerous prostate cells anywhere in the body without hurting non-prostatic cells. The vaccine would most likely affect which of the following immune cells? And this question is asking you, really, what do these immune cells do? Is this T cell or B cell immunity, basically? And this would be cell-mediated immunity. We want to attack self cells of the body, and that is a T cell's job. The B cell is humoral, and it uses antibodies. The T cells attack cells. So answer choice A is the best answer.
Passage 10. Somehow I got another organic passage. Not complaining. Question 198. In reaction 1, the alcohol acts as. So let's take a look at reaction 1 and the diagram. And we got the alcohol, and what's going to happen as we go from reactants to products here, we're going to remove a carboxylate group and replace it with the OR from this alcohol. In other words, we're removing one negatively charged species and adding to this compound another negatively charged species. We've got a substitution reaction of the nucleophilic type, so the alcohol must be acting as a nucleophile. For 198, the answer is A.
Yeah, and just to clarify here, the alcohol almost always acts as a nucleophile. It loves to behave as a nucleophile. The two lone pairs of electrons love to go after that. And when you have a carbonyl, it is going to it loves to receive a nucleophile because it has a partially positive charge. So they're a great pair with each other. The carbonyl will take on the alcohol and lose whatever it had before.
Great. Question 199. Benzyl alcohol is refluxed in an excess of acetic anhydride, as shown in reaction 1. At what temperature is the reflux carried out? Now, it tells us in the passage, in the first paragraph, the last sentence says, in refluxing, the solvent is continuously boiled, condensed, and dripped back into solution. So if we're going to reflux, we want to keep the solution right at about the boiling point of the solvent. According to the question, the solvent is going to be acetic anhydride. According to table 1, acetic anhydride boils at 139 degrees Celsius. So if we're going to reflux it, we got to do it at 139 degrees Celsius. 199 is B. 200. Which of the following alcohol mixtures would separate most efficiently using distillation? And to me, I sort of rephrase this question as, which of the sets of alcohols listed, which set of alcohols has boiling points that are farthest apart? Because if they're farthest apart, it's going to be really easy to boil one off while the other one stays liquid. So let's go through answer choices A through D and just compare the boiling points of the different compounds. A says isoamyl alcohol and isoamyl acetate. Isoamyl alcohol is 130. Isoamyl acetate is 10 degrees difference here. So answer choice A is 10 degrees different. B says propyl alcohol and propyl acetate. Propyl alcohol boils at 82 degrees. Propyl acetate boils at 102 degrees. That would be a 20-degree difference. So that's clearly larger than A. A must be incorrect. C says benzyl alcohol and benzyl acetate. Benzyl alcohol boils at 205 degrees. Benzyl acetate at 206 degrees. Almost the same. That's clearly nowhere near 40. C can't be correct. And finally, D says cyclohexyl alcohol and cyclohexyl acetate. Cyclohexyl alcohol boils at 161. Cyclohexyl acetate boils at 173. A 12-degree difference, not as great as the 40-degree difference in answer choice B.
difference.
I'm sorry, 20-degree difference in answer choice B. So the best answer for 200, B. 201. Reaction 1 can also be run with propionic anhydride. And I've drawn the structure, propionic anhydride. What would be the structure of the ester product when N-propyl alcohol is reacted with propionic anhydride? So N-propyl alcohol is going to be a propyl chain, 3 carbons with a hydroxyl group. And of course, if we get a parallel or a similar reaction to that we saw in reaction 1, what's going to happen is the oxygens on the hydroxyl group are going to act on this carbonyl carbon, and replace this group. So this will be our leaving group, and we'll be left with an ester that looks like that. And let's find that ester amongst our answer choices.
So it has 2 carbons on the left of the carbonyl and 3 carbons on the right side of the ester group.
Great. So it's going to have 2 carbons. That's going to eliminate answer choice A immediately because that only has 1 carbon to the left of the carbonyl. A is out. Actually, C and D are out. D is our original propionic anhydride. That's not going to be the ester product formed. D is out, and C is just kind of weird. I don't know exactly what happened there, but that's certainly not the mechanism being described here.
So B is the only one, and C is not an ester. C's got to go, so it's got to be B.
Best answer for question 201 is B. Question 202. How many resonances would appear in the proton NMR spectrum of benzyl acetate? So I've drawn benzyl acetate up on the board, and we're looking for the number of resonances or the number of different protons in the NMR spectra for this compound. And when I look at it briefly, what we're looking for is the number of different protons. Obviously, we've got one type proton here, so that's going to be one group. We've got another proton. Remember, there's going to be hydrogens at each position in the carbons in the ring, but we've also got, and they're intentionally not drawn, we've got 2 more hydrogens which are going to differ from both these and these. So we have 3 different types of hydrogens in this particular compound. 202, the best answer then is D.
Now, I often get questions about these hydrogens. People will say, well, this hydrogen is not the same as this one, it's not the same as this one. So we have 3 different hydrogens here on the benzene ring because of the position of this. That's true, but it turns out these are coincidentally the same. So you still only get 3 peaks. So that the hydrogens on a benzene ring actually turn out to be coincidentally the same NMR.
And if you were struggling with that on the actual MCAT, 3 is the largest number that they offer as an answer choice.
Exactly. They did it on purpose. They would not give you 1, 2, 3, 4, 5. They wouldn't give you 5 as an answer choice. And they did it on purpose here. They only gave 3 as a top answer choice.
Great. So 202 is D. Finally, 203. Of the compounds listed below, which could be used in place of the acidic anhydride to form the same ester. So again, we're looking at reaction 1, and we're saying what could form the same ester product reacting with this alcohol. And the key here, and this is a must-know reaction for MCAT, you must know that you react an alcohol with a carboxylic acid to yield an ester in an esterification reaction. The byproduct of that reaction would be water. That is a must-know reaction for MCAT. Carboxylic acid plus alcohol yields ester.
203, the only carboxylic acid is choice A.
A.
Okay, passage 11, question 204. What is the role of the Purkinje fibers in cardiac contraction? And this is just general knowledge that you need to know. The Purkinje fibers actually bring, if we draw out the heart here, and then here are the atria, and then here are the ventricles. The Purkinje fibers rush the signal down the septum of the ventricles and cause the ventricles to contract all at once. And this is because the ventricles need to contract in unison to push that fluid out. They are actually the pumping force of the heart. So the best answer choice here is to synchronize the contraction of ventricular cardiac muscle. Without the Purkinje fibers, the signal is going to go from cell to cell very slowly, and that's what it does throughout the atria, and we can't allow that. We need to have all the cells contracting at once or close to it with the ventricles. So answer choice B for 204. Question 205. The sinus node is located right there. It's the right atrium, and you're looking at a guy on his back here, so this is the right side, not the left side. Okay, and answer choice A for 205.
You just have to know that.
206. Strong stimulation of the vagus nerve can block transmission of the cardiac impulse through the AV junction. However, in a phenomenon called ventricular escape, the ventricles usually begin beating within 5 to 20 seconds. Which of the following is the best explanation for ventricular escape? So the signal's blocked, but yet the ventricles will start beating on their own. The passage gave a hint to this in the second paragraph there. Although the AV node and Purkinje fibers are capable of autorhythmicity, they're capable of beating on their own. Auto is self, autorhythmicity. So we have choice C here for 206. The Purkinje fibers begin to contract rhythmically on their own. And your hint was in the passage there. Okay, so 206 is C. 207. Which of the following ions is most responsible for depolarization of ventricle cardiac muscle? If we take a look here for the ventricle cardiac muscle, it's going to be the sodium. And in the action potential, the depolarization for the ventricle cardiac muscle, this is the depolarization here, it's going to be fast-gated sodium channels. And actually said in the passage, in
the first paragraph.
Yeah, the middle of the first paragraph there. Unlike ventricular muscle cell membrane, so at high resting potential of the sinus node membrane, most fast voltage-gated channels are inactive. So apparently in the ventricles, the fast-gated sodium channels are not inactive, and the fast-gated sodium channels cause depolarization. By the way, you should know this for most action potentials. Depolarization is caused by the opening of fast-gated sodium channels. So that is answer choice B for 207. For 208, tetrodotoxin found in marine pufferfish, a Japanese delicacy, competitively inhibits fast voltage-gated sodium channels. So this is going to stop the fast voltage-gated sodium channels. Which of the following most likely demonstrates the action potential of the SA node when exposed to tetrodotoxin? All right, so we're looking at the SA node. The key here is the sentence I just read actually from the middle of the first paragraph. Unlike the ventricular muscle cell membrane, at high resting potential of the sinus node membrane, most fast voltage-gated sodium channels are inactive. So in other words, the sinus node is not using fast-gated sodium channels to cause depolarization. So if I block, those are already inactive. So if I block them, it shouldn't change anything. And what that leaves then in the answer choices is the answer choice should look just like what it does in the passage, which is choice A. So it should look identical. Here is my sinus nodal fiber right here, so my action potential is not changed by tetrodotoxin because tetrodotoxin blocks the fast voltage-gated channels, which the sinus node does not use. So it should look just like this, which is A right there. B is ventricular, C is some kind of modified form, it wouldn't change, and D seems to be some kind of modified form. that would not work. So best answer there is A.
We've hit the last set of freestanding questions, starting with question 209. It says the cell membrane demonstrates selective permeability to which of the following? In other words, allows things across sometimes, or allows this thing across sometimes, but not others. And of course, when we talked about the cell membrane a couple of passages ago, John talked about a facilitated diffusion protein that allowed the movement of glucose across the cell membrane when it was there and disallowed it, essentially, when it was not. So that would be a sometimes or a selective permeability, and that would be, of course, answer choice B, glucose.
Right. Cortisol is a steroid. Cortisol can freely move across the membrane because it's lipid soluble. Water is very small and can freely move across. Platelets can't move across. They're much too large. Glucose is the same size as, say, fructose, when glucose may move across, and fructose being blocked out, selectively permeable.
Great. Question 210 asks for the IUPAC name for the molecule shown here. Of course, we have, at a minimum, 1, 2, 3, 4, 5 carbons in our chain. Eliminating answer choice D, that would be a butene, or only 4 carbons. So we have to choose between the pentenes listed in answer choices A through C. When we have a double bond, the double bond is going to get priority in naming. In that case, we'll start here. This will then be the second carbon. This will be a 2-pentene, eliminating then, excuse me, answer choice B. And then, of course, we've got a methyl group, and you can pick your favorite spot for the methyl group because the chain will still be 5 regardless of how it goes. We're going to have a methyl group here on the 4th carbon. This must be answer choice C, 4-methyl, 2-pentene. 211. In the debilitating disease elephantiasis, excess fluid accumulates in the tissues. This is most likely a result of what? Now, there's 2 answer choices here that I think go up for possible status. That would be A, disruption of the capillaries in the affected area, or C, blockage of the lymph vessels. And of the 2, I think clearly the blockage of the lymph vessels is a better answer choice. You need to know that the lymph system is an open system that essentially functions in 2 places. 1, it returns fluid back into our body system, and 2, its function in immunity. If you chose A on this one, disruption of the capillaries, what you did was you made an assumption. You assumed that something was going wrong in the capillaries and that it was backing fluid up. That might eventually lead to a fluid buildup, but I think clearly C is a better answer choice. Again, the lymph system is for moving fluid back into the heart. 211, C. All right, to answer question 212, we have a special guest appearance by John Orsay.
All right, let me take 212.
Okay, we're looking at question 212. A pneumothorax is an opening in the chest which allows air to pass between the outside of the chest cavity. Which of the following would most likely occur due to a pneumothorax? So here we have a guy, here's his lungs, and he breathes by opening his mouth and allowing air down the pharynx and into the lungs. And the pressure here is less than atmospheric pressure. So when he opens his mouth, the air is forced into the lungs and the lungs are forced to expand because this pressure is less. Now, if we have a hole, a pneumothorax, a hole basically in his chest cavity, that means air can go in this way and this compartment becomes atmospheric pressure. Now when his mouth opens, air is not forced in here because it's the same pressure on either side. So what we have is a collapse of the lungs. The lungs are not allowed to expand, and that would be answer choice A, collapse of the lungs. Okay, question 213. A certain autosomal recessive disease affects 16% of the population. What percent of the same population are likely to be carriers without the disease? All right, so it's an autosomal recessive disease, and we have 16%. So let's say that let's just call the disease, this is the genotype of the person that's diseased. This would be a carrier, and then this would be a healthy person. And we're saying that 16% of the people have this genotype. Now there's a formula here that you want to know. It's just the binomial theorem, p squared plus 2pq plus q squared, and this equals 1. And we know that p squared then is going to, well actually q squared is going to be the number of people, the percentage of people that have this genotype. So q squared equals this fraction, 0.16. And that would mean that q is going to equal 0.4. We also want to know that P plus Q equals 1. So these are the two formulas that you need to know, this one and this one. If P plus Q equals 1, then P must equal 0.6. So this percentage here would be 2PQ. This would be the people that are carriers. So that would be 2 times 0.4 times 0.6. 0.4 times 0.6 is 0.24 times 2 would be 0.48. 48% are carriers. 16% then have the disease. And then what do we have left over? 58, 64.
Well,
So
you've answered the question.
right, so we have 36% here. And that answer choice then is C for 213. The percent that are carriers are 48%. Notice something here. The people with the disease, the terminology is they are not carriers. Oftentimes students will say, well, this guy's a carrier. He just has 2 of them. That's not correct. This is not a carrier. It's a diseased person. This is a carrier, and then this is a healthy person. All right, question 214. Which organ is involved in blood cleansing, blood storage, conversion of carbohydrates and proteins to fat, and secretion of bile?
Alex, what is the liver?
That's correct, Jordan. And my name's John, by the way, not Alex. Answer then is B, the liver. And that's it for test 2. Thanks very much.